This is the audio test. Okay, why do I not hear myself? Test, test, test. That should work. Why? What? Oh no. Yeah, there was my voice. Okay, good. Why is there such a big delay? I set the delay to... Oh, normal delay. What does normal delay mean? For good evening, hey Gordon, hi. That was that you are in here very quick. Hi. What does normal latency mean for YouTube? No one knows. So yeah, there's this little bit of a delay. You hear me? Hey Steve, how you doing? How's everyone? You missed me, Satish? No need to miss me anymore. Thank you for all the help videos. You are very welcome, and your first project almost done. Hey, you've got a good start in there, and like years and years of PLCs coming up. This is a topic that will be there for a long time from here on out. Hello, everyone. Hello. You want to be more great? You're asking the wrong one. I don't know. I don't feel great. I feel like I'm having fun. I'm doing good. But I have, of course, I also do stuff off stream. Who would have guessed I do exist? And I've watched some technical content on YouTube. And I will talk about a little bit there later on. But I've watched other channels a bit there. And I gotta say, sometimes I'm like, whoa, I don't feel stupid because I have some knowledge, of course, but I'm still like, wow, there's so many more knowledgeable people than me. They have so much real life experience, and so it's just great. There's so many great resources out there, and I've just been watching stuff, and I'm like, oh God, I feel so terrible because there's so much to learn. And I basically can do this TIA topic. Of course, I do know a lot of parts in automation, how a lot of things work, but still, this is not my apartment. This is just a backdrop. But thank you. Nice apartment. You say, wait, there's a green screen. You can sometimes, if I move a little bit wrongly, you can see my apartment, and there's just a green screen. Right? Einen schönen guten Abend. I don't live up somewhere. I also don't live on the ground floor, but I do live in an apartment, and it's like a normal standard apartment. Not even a good one, I would say. Hi, Hartux. Hi. Whoop, whoop, you made it. uh, perfect. And whoop, whoop, the sound of Hegamon. Yeah, that's how I sound. Yeah. Wie geht's? I'm doing good. I'm doing good. How's everyone doing? Hope you had a good start to your week. Mine was okay. It started snowing here. It started getting very cold. Okay, my weekly rant. I do those streams weekly, right? Hey, it's the fifth time in a row now. That means it's been a month, and now 1 month and like 2 minutes because I streamed like exactly 4 weeks ago was the first one. So this is like the first one started 4 weeks and 2 minutes ago. So hey, it's a full month. Perfect. Even though it's the fifth stream, it's a full month, right? Arrays start at 0 in most contexts. Not in all contexts, but in most. Yeah, so it started snowing, and I gotta say, like, my rant here is I do live in an apartment, right? Now that we had the apartment topic, and my apartment has electric heating, which was a big thing like 50, 60, 70, 80, like a long time ago, right? It was a bigger topic, especially in bigger cities, and I do live in a very old building, old apartment, not really an apartment, but like it's a building, and this electric heating would cost so much to replace, so I gotta rely on electricity to heat my whole apartment, which is incredibly expensive. Oh God, this is so. Like, if I want to heat one room per day, that is like 3 to 5 euros, which is so much. Like, if I have, or I do have 3 of those electric heaters, and I have to turn them on the day before, right? So because electric heating charges throughout the night, where electricity is cheap, or cheaper. So I've got a special contract for that, but it's still so incredibly expensive. Oh my God, it would be less expensive to just have a campfire in the middle of my room every day. with all the maintenance. I mean, no, that would be more expensive, but still, it's so expensive. God, I wish I could change it, but like replacing it would probably be like 40, 50, or 30 to 40,000 euros, because it is like it would have to be replaced for the whole house, and so crazy. Yeah. So basically paying like 3 euros per day per room. And because it got colder, God, I'm paying so much money just for heat. I could install. Yeah, of course I could. It's not the question about I could. It's a question about if it would be like profitable and many more factors. And also I live on rent, right? So I won't just rip out like the heaters here and replace them with something. This would just be a financial loss for me if I would be doing those replacement things. Not gonna happen. Hey, they're from Zimbabwe. I mean, at least almost the same time zone. Oh, that's something. Vodka would heat me up. Oh yeah, I know. I do have I do heat stuff. I do have like a running pad. Usually when I stand at my desk right now, I don't run, but I walk like quite a lot each day, so I don't get cold, and so on. But it's still a pain. Perfect. So that was my rant here. But it's getting cold. I'm still good, right? It's like meckern auf hohem Niveau, as we say in German. Like it's unnecessary to complain about it. Perfect. Alrighty. I've been excited. You have been excited for a week. Why? Why would you? This is, but I have also. I've Abu Dhabi. At least you've got it warm in Abu Dhabi. I don't. Yeah. PID was amazing. PID isn't done. Like preview for today. And thank you, Coit. Right. Name's always difficult. You've been excited for a week since the last stream, and PID was amazing. PID isn't done. I have decided PID isn't done. We will touch many more topics in the process today, but I do have I do come prepared with my official like preparedness here. Wait, where are my buttons? I do have buttons on the side here. Me and big, yeah, me and big. That's the good one. Hey there, I remember you from Congo from last week. Welcome back. Wait, oh, I'm the other way around. That's always difficult. That's not the thing that I wanted to. That's just the thing. That's just the topics. So if you have topics, always toss them in there. I try to put them in the list and then talk about them as I can. As always, I'm gonna like this. I have to do it. It's a semi joke, but I have to do this. Always plug the Udemy course here, like the beginner's course. You don't have to do anything with it. I'm just plugging it. It is an ad. Do I have to write hashtag ad or advertisement if it's my own stuff? I probably do not. So if you want to support me, click the link and so on. You know the drill. Don't have to do it, right? But I have to, like every time I have this open and I get reminded, like, oh, this is something I could do. I almost forgot about it if I wouldn't have it open. So that's it. Sponsor talk over. It's not sponsored. It's myself. I don't know how this works. But we've got so many topics, right? And I still want to continue because last week was a lot of fun for me as well. And I want to see more improvements to our system, right? To this. Now, I did not even talk about the topic that is listed on there, right? This here says PID with technology objects. Last time we did mathematical operations. We did PID. It was fun. We had traces in the progress. We talked about some topics, but we didn't touch the main topic, which for me was technology objects, which I want to do today. I'll try to get there. Yeah, still better than to flood your basement. Yeah, Artux, if you flood your basement, of course that is shit if you have like those kind of problems, which I don't have. Right, those systems. I've been living here for a long time. I had to, like once I had problems with the heating system. Didn't have it. Like I was a technician. Took a day. That's it. It's great content. Thank you, Brian. Thank you very much. Oh, Node-RED. Node-RED, I would have to put this in other tools, I think. Right? So my girlfriend always talks about it. She's a web developer. She talks about Node-RED, I think. And I'm always like, yeah, sure. It's one of those topics where I say, of course I know what it is. And of course I do, because I can Google things. I've definitely heard about it. No, low code programming for event-driven. I've got it written down now. But I've heard about it, but I've never used it. Are we finally going to be doing the PID compact? Yes, not fully yet, right? We're building up to it because there's some topics I want to talk about in the process. Subscriber only YouTube videos. I don't really. I know Dublin. Question here is if I have thought about like subscriber only YouTube videos. But I'm not really doing this for the money, right? This is like me plugging my Udemy training here, and so I do get money as like an add-on, of course, and I do make some money out of this with ad revenue and all the views and so on, and the members and such. But that's not my main goal. I want to keep like the streams accessible for everyone, right? Code Assist is already on here, I think. Isn't it? Don't we have Code Assist on here already? Of course, Code Assist. Sorry that I didn't have that. Did I hear about TI version 20 yet? I have not really used that. No, I haven't been updated about it. I will be using it as soon as it's really there, but I haven't done it yet. Yeah, Windows 11 was a big problem, but not getting back in there. Okay, so topics will go to the side here, right? And I do have my agenda here. The very official one. I like everything I do is high quality, as you can see. Small talk, we're in the middle of it. This is going to be done in like a minute. There we go. Hey, PLC Tech Academy. Hey, hello. What we need to do, because I am going to face a problem today, which will introduce more topics, right? Because this is week number 5, and I hope I'm not showing. No, I'm not showing anything. And one problem that I have is this ran out like to yesterday. Right? Not this, but the PLC Sim Advanced, which will cause problems. I don't have a PLC Sim Advanced license anymore right now. I could get one and so on, not the topic. But this leads into more topics, right? But this will open it up. Like I do have, of course, a TIA Portal license, like one that I bought. But PLC Sim Advanced will keep us from doing things. Like right now, we will have some problems with simulation. That opens up the topic there. You will continue supporting me. Sure, watch my videos, join the streams. That's all the support I need. Yeah, the systems here, like all of the stuff, like my heating system has been there way before me, and I'm old, not too old, but I'm older, getting older. Yeah, there we go. So we will face this problem of like our program needs to be updated. Let's say we will need to merge 2 projects for whatever reason. Then I want to continue with the PID, which I will not blow up too much. If this doesn't work perfectly, the PID, like the IND part, this way, right? Then I won't concentrate too much on math this time. Last time we did go in there and analyzed quite a bit. This time, if it doesn't work, like from the get-go on, it's fine. I will spend like a bit of time on there, of course. But as soon as this works or doesn't work, we will switch over to a technology object. Right? The whole PID topic is great that we have created this like last time, like manually, I would say. Right? Our own PID controller, which is always a possibility, but in industry you would not go there. Right? You wouldn't create your own thing. Especially in automation, you have to rely on technology, on topics that other people have already like created to perfection. Right? So that's what we will do. I am older than you, yeah. You guys can guess how old I am. Oh, God. You will probably be right, but yeah. But age is also a question of your mind, right? So in my mind, I still feel like mid. I won't say anything more. I still feel young in my mind. And body is also fine, luckily. Yeah, and then we'll have an outro. I do have one more topic I will go into in the outro because I want to. I'll be having fun a little bit there. But yeah, there we go. Okay, so that's our quick plan for the day here. And I try to keep it 2 hours and not 2.5 like last time. So, alrighty. Everyone good to go? Then I would say we jump in. I do have a button. 37. That is correct, actually. how did you guess like instantly the correct one? Instantly correct. Yes, 37. Hey Tundle, hello. How did you like the first guess? I thought it would take at least 2 or 3 more guesses. Okay, last small talk here. Last small talk. Um, so I've been working with Siemens, of course, and I like for a longer time. When I was like in my mid 20s, I would say like 22 or 23, I was already doing trainings, right? And I had a training with a co-trainer, so I was the co-trainer, and there was another trainer with me. That other trainer is like I don't remember exactly how old he was. He was like 6 or 7 years older than me. Right? So I was like, let's say I was 22, 23, and he was 30. And we asked the course participants, like, who they thought was older. And everyone agreed that I was the old one. I was just 23, he was 30, and I was like, yeah, okay. I'm old. I've always been old. Ah, good, okay. I know I'm red. You see, like those stories. This is terrible, terrible. Okay, last story then small talk. Also, like when I was like 13, and this is not how I look like, but how I sound like. Like the microphone and everything, of course, this distorts the voice a little bit. So online I sound different than in person. When I was like 12, 13 years old, I already sounded like a 40-year-old man. My voice was old. Some neighbors asked my mother who the old man is that is living with us now. Because of my voice. But it was the age where a young man's voice changes, and they were like, who is that? What's this voice? And I'm like, sorry, I sound old now. Oh, God. Alrighty. So, old man here. Uh, now I feel bad. No, I won't feel bad. It's okay. Yeah, that's how I am here. Okay. Let's go into technical topics here. Small talk done, 15 minutes, perfect. So me and small. Right? Let's look at a problem that we have now. So, um, oh, Dayton, you only start realizing getting old based on a hangover after a night out. Yes, that's been like 10, 15 years for me already. Software units. Software units. Perfect topic. I think I have it on my schedule somewhere, but software units definitely. Portal features. That's an easy one, actually. Which, easy, like quotation marks, but still. Okay. One thing I forgot to do, of course, is for TIA, we need to zoom in. You see I'm using 3-screen setup. Perfect. Hello to my Windows settings here. There we go. So, there we go. So now we do have a problem. Thanks, Ramdane, by the way, for the hint of software units. It's a great topic. So now we do have a big problem right now. And everything here is not made up, it's real problems that we have, but in our simulation scenario, we currently do have a problem. If I open up the project from last week. Hi, hero. The hero bias. The bitrate should be fine. Let me see. Bitrate is 8000 kbps, so bitrate should be okay. Not 46. No, bitrate should be fine. Maybe you have to reload or so, but bitrate should definitely be fine. Let me see. Stream quality? No, stream quality should be good. Your internet on your way home. See you soon, Hattix. Have a good trip home. Okay, now our problem here is the following. Right? Our problem is the following. And it's this. Last week we had the PLC here in our project, and we loaded it into PLC Sim Advanced, but as to connect to Factory IO, right? So Factory IO, which I will open up now. And this all leads into another topic. So that's a little bit of a story now, but it leads into another topic. So we do have the level control. So last week we talked about the level control here, which was quite fun. So I had fun, so I want to continue with this. So in this level control, right, we connect this with a communication driver. Last week we used the communication driver that is PLC Sim Advanced. They just have different communication drivers there. Now, this works with PLC Sim Advanced. So that's just, it doesn't matter if it's the simulation or anything. This is the real situation right now. Leads into a topic soon. Now, what we don't have anymore is PLC Sim Advanced. I will have to switch over to S7 1500 version 20 of PLC Sim here. Right? Now, why is that relevant? And I will start drawing more things. Now, why is that relevant? Why isn't this like a vector graphics paint? Now, why could this be relevant? We do have Factory IO, which is our simulation software here, right? So that's there, and we have PLC Sim. Right? And currently, our project, our TIA portal project. Well, why is it so? Doesn't matter. Currently, our TIA portal project, right? We download into PLC Sim Advanced, and PLC Sim Advanced connects to Factory IO. So that is a pretty normal setup. But so PLC Sim Advanced is a controller, of course. Right? Could you explain simply what variant type? The type variant is what it says. It is a varying type. It could be anything, right? It's not something that is always the same. It can change. Like it's a data type that is a variable in itself. Sounds strange, but that exists. Yeah. So that was fine. Now the problem that we do have this week or now, can I copy and paste in this part? Can I cut and paste? Oh, I need more tools. The problem right now is that I do not have PLC Sim Advanced right now. It doesn't matter, right? This is just the part of the story here, right? So this connection won't work anymore. Now what we need to do, and this is where it gets important, right, is we will now use the normal version of PLC Sim. So this was Advanced. Now the problem with the normal version of PLC Sim is that Factory IO needs a special project to run together with PLC Sim, right? So a special project. Special project. Right? So we need this special project. We cannot use the project that we had. We have to now also use this special project. So this special project that we need to use is something that is already prepared by Factory IO. Right? Now, one thing that I definitely want to still do, of course, is we already have code. We already have a project. We already have our old project, right? Not old, but our existing project. So we have an existing project. So now, what is the problem exactly here? Well, those two projects are two separate things. What do I have to do is I have to bring both projects together, right? Which is a pretty normal thing to do. In your day-to-day life, when you're programming, when you're doing stuff, you will have a lot of things already programmed in other projects. You will build up like this knowledge base somewhere with stuff that you have done, which will grow over time, right? And then you will remember, hey, I already did this at one point. So the last thing that you want to do is to redo everything, right? So our first topic here is we want to bring two projects together. How do we merge projects in our case? Now there's many different possibilities, but the thing that we will do is we are going to have some library management here, right? It's a true story. Of course, it's a true story. Yes. So we will have some library management here. What I want to do for all of our upcoming TIA Tuesdays, and I will also publish this, exactly Artico, is I want to create a library. Right? So we will have an official TIA Tuesday library. Right? Now, what I will put into this TIA Tuesday library, and I don't know how and where to upload it yet, but I want to make this public, and I'll keep you posted on that, where I will have this. It might just be that I upload it in my cloud, in my OneDrive, and then publish it or so. But this TIA Tuesday library, right, will now be my central point. If I need something from an older project, right, I don't have to reopen this old project if I have my library management like done correctly. Right? So the first topic here is creating this TIA Tuesday library. Right? And talking a bit about library management, about managing your code and stuff like this. Right? There we go. And then in the end, of course, this library will serve us to create like one project that can combine everything. So let's go. Right? So the first topic, we do have, right, the project from last week. Right? And I will give this PLC a fitting name. This was our P controller. Right? Now this is the P controller from the last time, right? It's not perfect. This is isn't done, but the whole controller is P controller now. Now I do have the second project, which I will open up in a second here, which is, I will also talk a little bit about version control. Yes, Kaio. Question is there, is it related to version control? Simply said, yes. I will touch on the topic a little bit. So the second project, so the first project is this here, right? It's literally the program from last week. I did not alter it. I think, did I alter it? I think I did not alter it. Might be. Very good question, Artico. Is there version control in TIA? I will talk exactly about that. So yes, this is the program from last week, I think. I think I have played around a little bit with it. I hope I did not change anything. But yeah. So now, what I want to do with this... Oh yeah, this can go away. We didn't use that. 1 second. I just clean up like this. This is now the clean program here. Okay. Now, from the last week's program, what I want to do is I want to create something that is independent from this project right now. Let's see. Right? Now, this independent thing, the first there is quite easy. I can go here on the right side to my libraries. Inside of the libraries, you will see, oh, I have global libraries, and I, in preparation, have forgotten. Hey, Kyoku. Hi, how you doing? I have forgotten to actually delete the one that I did in preparation. So I'm going to... you didn't see that, right? You did not see this library. You did not. It wasn't there. I did that in preparation. I usually prepare like stuff that I do here. So now, when I open up libraries... when I open up libraries, we do have already access to some pre-made global libraries that TIA has. Right? We have the project library, which I will talk about, which let's actually talk about the project library first. Right? The project library here is a quite simple thing. This is, when you save your project, this is always saved together with the project. Right? It is a part of the project. Now, imagine the following thing. You are programming any block, anything, doesn't really matter. Right? Let's say we are programming a block. This is now random code, right? This block is not completely done, for example. Hey, Rupert. Hi. Right? This is not completely done. It just exists in your PLC. Right? Now, what... And you think, oh, this is good, but I have to run my other code. Now, one big problem that you will have when you compile your PLC, obviously, this block belongs to your PLC. So what do you have to do? I mean, there's another way, but what would be the main way of you right now if you want to download your program? Well, unfortunately, you have to delete the block. Right? Because downloading a PLC is always, everything has to be consistent. Right? There is another way to download the program and not downloading this one block. Different story. We don't want to look at this. We could also use a software unit actually for this. I'll make that like maybe next week's topic or so. Or maybe I'll talk about it, but not right now. But this block is like, damn it, I have to delete it. Because that's how the PLC works. Or what I could do, and that is why we have the project library mainly, is I can take any block or any hardware or any HMI, anything. Right? Could take the block, pop that here into my project library, and this is now a so-called master copy. I can delete block 1 here. I'll just delete this from my project. Right? But you see, I do still have the master copy in my project library. So even if you delete something, you can have like a master copy. Yeah. Or you could use dummy program as well there and stuff. But yeah, hey Tetra PLC. Yeah, but I prefer this method. So right now, and now I can continue with my normal program, download it, compile it, everything's fine. Right? If I do want to continue with block 1 now, right, I could just simply now pop that back into my program. And now it is there again. If I need it another time, I can drop it again, and so on. Right? That is the general idea of libraries, right? Of the project library here. There is also types here. I will talk about types in a second, but for now we have master copies. You cannot change the master copy anymore. Once you have put that into your library, it's there. You can delete it, obviously, but you cannot change it anymore. Now, you could also put a complete PLC in your master copies here. Right? Now I can completely, I have the complete thing. So if I need that a second time, let's say my project has twice the same PLC, hey, make a guess. I just pop that in there, give it a different name, done. Now a master copy is, as it is, a master copy. Now this is especially useful if you have, I read WinCC there a second ago from Arteco, right? In WinCC you have those prepared things that you usually take from a library, right? And once you have something like a screen prepared, you can always retake it from the library. Now, the project library is always just content of our one project right now. That's not what we want. What we need is, just hiding right behind me, is a global library. Right? So let me open up my global library here. In the global library, right, I can create a new one. So I will now create a new library. Right? I will give this the name TIA Tuesday. Lib for library. Right? TIA Tuesday lib. And usually if you do something, the type should come first. So I will call this lib TIA Tuesday. There we go. So this is created by me. This is all the content we created together on TIA Tuesdays on live stream. Follow for more. Like and subscribe. Sorry. There we go. Right. There we go. So I created now a global library. This global library is not connected to the project, right? It is a separate thing, and I forgot to. Damn it. Did someone see the path where I saved it to? There it is. TIA Tuesday desktop, TIA Tuesday lib. Perfect. I selected the correct folder in before. So this library now is a global library. That also means if I take my P controller PLC right now, I can just pop that into the master copies, and any other program that I have on my PC can copy this. Right? It's just this one element. Now, in our case, what would even make more sense, and I'm going to take a minute to prepare this, is not to have the complete PLC, but to take a function or a function block in our case and use that function block as a master copy. That's what I will prepare here for a second there. It's going to take a minute because I need to clean up the block here. Yeah, it's going to take a minute, but that's one of the big topics today. Let's see. Long time no see. I was on Overwatch. No, I was probably on in World of Warcraft, but on Blizzard, yeah. What is the short story behind the name? I don't really have a story there. So what's the short story about my name? I think my brother, for some reason, called me like Hager, which is my gamer tag. If you find Hager, that's me on the internet. And the Merle was a couple of friends and I, because some creatures in video games, they make funny sounds. They make like murr, and us idiot friends, we were like, hey, let's all put that like as our suffix in our name, and then all of us were named whatever name, Merle. So there's a couple of us. 4, 3 nowadays, but yeah, a couple of us. So okay, now the great thing that we want to create, and we can learn from this, right? We're here for learning and a bit of entertainment. This tank function block that I have created here is actually terrible. It's not like terrible, but it's definitely not good. If you want to put a block into a library, you want to make sure that you can use that block in other projects as well. Right? So we want to have good blocks. This one is not right now. If I go into the tank here, what we should not be doing is to have access to a global variable. You see, this level meter is accessing the global address ID30. This ID30 exists in this PLC. It might not exist in the other project where I want to implement this into. Right? So this is bad. This ID30 must not be here. The same with our set point. It must not be here. The same with our fill valve. It must not be here. The same with our... That's it, I think. That's it. Those are right now the inputs and outputs to our block. So this block on the outside should not look like this. It should have some inputs and some outputs, like the ones that I just talked about. Because I want to use this in other projects, and those here do not exist in other projects. So the first thing that I will do is I am going to create level meter here as an input. Level meter. I am going to look at all of the variables here that I need as input. Set point. Of course. What else do we have? Hey, we have the fill valve. The fill valve is an output though. Right? There we go. Let me check. That should be it. Now, the one thing that I still need here, of course, those are all not like Boolean. I want to connect the correct thing. In the case of the level meter, let me just check what the data type here is. Oh, level meter is real. So level meter should, of course, be real. Right. Now, set point. Oh, and set point is one word, right? I think in English, it's one word. I think I can write it as one word. Yeah, pretty sure. Maybe let's not call it level meter. Maybe let's call it just meter. And the output here is just, let's say, output. And let's not call the meter. Let's call the meter, very generally speaking, input. Right? That is our input. That's our feedback value. Could call it anything, right? Yeah. Now, one thing, I'm talking about this, right? And let me just fix the data types here. So this is also real. By the way, if you hover on top of a variable, it will give you the data type. If you didn't know. So that's also real. And the fill valve should also be real, I guess. Yeah, it's also real. Okay, perfect. Now, I'm just saying this right now. And is there a way for you to believe me? I mean, of course, I would never say something that's wrong. I can be wrong. But if you ever create a block, and you want to confirm if you have created a good block. A good block can go into a library. A good block uses standards, right? You can, after compiling it, so you have to compile the block first, right mouse button on the block, into its properties, and in the properties we do have the compilation. Now inside of the compilation, if you scroll down a little bit, it will actually tell you the so-called library conformancy or library conformance. Now this library conformance, what we want is it should say, yes, this is perfect. This uses standards. You can use this block in any other project. Right now, what does this block actually say? Warning, the block contains direct access to inputs and outputs, or indirect access to memory areas and some other stuff, but the block contains direct access to inputs and outputs. True, right? We have the fill valve here and the level meter and the set point that is access to global variables. The problem with global variables is they do only exist right now in this PLC. They might not exist in any other projects, right? In any other PLCs, in any other projects. So you want to create your blocks, and that's not just Siemens, that's not just PLCs. That is overall programming, I would say. PLCs use the PLC standard, so we should keep the standard alive here. Nevertheless, this is a good rule for everything, right? So what we should be doing right now is we should make sure that our block does not contain any external variables here, any global variables. So instead of my value of my level meter input value here, I want to have a more generic input value to my block. Now you see this input value, it could be a level, it could be a temperature, it could be a brightness, it could be a weight, it could be any physical, any value, right? This makes it much more flexible. And I will rename this rescaling input. There we go. And now internally, I will not rename those things like level scaled and stuff, but I'll actually right mouse button, rename tag. I will do that, input scaled. There we go. Let's clean up. I said let's clean up, and if I publish this library, I want this cleaned up. Right? Rescaling the set point. So this is now a global set point. No, this should be a local set point. This up there. So I'm going to pop that in here, right? Percentage set point scaled. There we go. Perfect. Right. Now the fill valve again, right? This fill valve is our output. So I want to replace this with the output here. Right? I want to replace this with the output. Every time I have the fill valve, I'm going to now have the output. Now this block won't be perfect. It still has constant values here. Those, like the tolerance, for example, have that. Let's have that as an input. What is this? Real? Yeah, it has to be real. Let's say tolerance. Nah, it doesn't matter. This is not perfect. I could make this block perfect, but we don't need to. I just want to emphasize on things. So now I did not use any global variables anymore, which I did. The fill valve still here. Did not see you. There we go. Now, the thing now is, all of those things have been replaced. Now, if I recompile my block, it should actually tell me the very important feature here. This object is library conformant, meaning I can take this function right now, or function block in this case, right? 1 second. Yeah, I can take this function block here, the tank, which I will now call not tank, but I'm going to give this a nicer name, like the Hager PID, which ain't perfect. That's a bad name, but nevertheless, right? This block now is library conformant, and it right now is just let's call this Hager process controller. Not perfect. This I can pop into my master copies here. And now I can use this in any other projects. The same way as we have always been using, for example, counters, the same way as we've been using timers, the same way as we've been doing anything. Those blocks up here in the instructions are basically just library blocks. Right? Now there's system functions and so on, not going in details, but they are basically just library blocks that someone else has created. Like my Jaeger process control block, which isn't perfect. Yeah. You're currently doing the exact same thing at work. Standardizing code is actually quite important. Now this block is good, but you will see, this has a problem now. So let's actually, I'll just quickly fix this. Now you see, this block is also now easy to control. Because, hey, it needs an input, and if I remember correctly, the input here was my fill level. Fill valve? No, what was the level meter? Yeah, it needs a set point. Hey, that was my set point. And it needs an output. This was my fill valve. So now I can connect in and outputs. Now this, yeah. Now I could, if my set point, for example, doesn't come from the system itself, but from an HMI, I could just have an HMI set point here. Right? That comes from somewhere else. Different variable. Yes. So Kayo asks, Coyote, probably a German name, right? Coyote, could that be? So Kai, I'm going to call you Kai, asks if this is irrespective of the version of the PLC. Yes. Simply said, yes. Because this library conformance, this library, of course, there are now blocks and things. There's other things that we have to obey when we create our blocks, right? So not using global variables is just one thing that we have to obey. But if it says the object is library conformant, you can use it in any project and any PLC. The thing is, password protection, I can get to that in a second. Now, the thing is with the, with now having, what did I want to say? Damn it, I forgot what I wanted to say. 1 second. Couldn't be, there's a saying in German, it could not have been too important if I forgot what I wanted to say. Now, oh no, the thing with the library conformancy is, and now I remember, still with the versioning there, the block itself has of course been created in version 20, and the library itself is also a version 20 library. Right? So unfortunately, you have to have version 20 to open the library. Theoretically speaking, it doesn't make any sense if you ask me, but that's how it is. As far as to my knowledge, I might like it is a version 20 library. There might be methods to have standardized blocks export in other means, but I don't know how exactly that would happen. But you have to have version 20 now to open the library. The block itself is theoretically, like, it is compatible with all kind of TIA versions, but it is not download compatible. That's like how TIA version, that's how TIA overall works, unfortunately. 2 more questions. The first is the stream being published tomorrow. Yes, as always, like, it will be there as soon as TI portless, as soon as YouTube is done with compiling it, with remuxing it. I don't exactly know what they're doing. And second question there is this usually password protected? So the blocks itself, I can of course password protect the library somehow, right? There has got to be like protection somewhere. Don't know exactly where, but you can protect the library, of course. The second thing is your block itself. Right? And that's also how those instructions, like the counter and timer operations here, right? If I pop in a counter here in my program, I click on cancel, I cannot really go on the inside, right? I cannot open up the block. Sometimes I want to look into it, right? Sometimes I want to look into it, like with this process block. Right now, this block is not protected, so everyone has access to the library, has also access to the block. Now, what I could obviously do is I could protect this block if I put it into a library, if I make it available to my colleagues and someone else, right? I can go here into the properties, and there is protection, and I can turn on the know-how protection. Password is password. If I forget the password, please remind me the password is password. Oh God, it's password. Password 123 exclamation point. Can I do this? I need an uppercase. Screw you. Password limitations are really annoying, so I will not turn it on. But if I have the know-how protection turned on, come on, I'll type in the password there. Blah. Wait, 1 second. Didn't I have like a text document with a prepare? I do have. I'm so well prepared. I can't believe how well prepared I am. I do have a text document with a password prepared. Like I do keep this as standard stuff, right? There we go. The password is this. In case something like this happens. This block is protected. Now, if I try to go in here, if I don't have the password, right, we cannot access it. I can still use the block. Right? I don't have to know what's inside to use the block. I know what's on the outside. I know what I have to connect. I know what the block does. I don't know how the block does that. That is now know-how protected, hidden behind the password. That would be know-how protection. The other protections here would be... how do I turn this back off? I want this. Huh? Did they change how... No, okay, they are on protection. I have to click. Remove the password, old password, and remove. Thank you very much. Now, know-how protection, you cannot look into the block. Write protection is you can look into the block, but you cannot change anything. And copy protection is you cannot use the block unless it is bound on the correct CPU or with the correct memory card. So you can protect this stuff. Like, of course, we're talking industrial data. Yeah, a lot of stuff is exactly, you can, as Greggy says, you can use the stuff, most of it, but you cannot look into it a lot of times. Yeah. I don't know why this still says it's password protected, but that is a bug, I guess. Old password, remove. The block is not protected. Okay. Oh, now it's gone. I did clicked on cancel, I think. Some of the inputs and outputs of blocks are gray in color, not black. But when I start monitoring the block, I can see some values. How is this done? So now, not going into too much detail there, Gautam. Those in and outputs. Now, for a block, each input, each output here has their own settings as well. Right? So if I go into the block and I go here on my input, I select an input and I have on the bottom here properties. Every input here, so you see, this is right now the properties of something called input, which is my input there, right? Let's look at the properties of my set point. Right? Now I can, for example, say I want to hide this. I can also say this should have a predefined actual parameter. Now, a predefined actual parameter would connect this one to something. Let's say I want to have something in the project that is the set point. It will auto connect to this variable if it can find that. Now there are, so generally speaking, there are some settings for each individual variable. So now if I save this block, now if I use this block, you will see, right? If I put in this block here again, right, I will not create an instance because it's not there. You see that the set point that I just changed the settings is not shown here. And if I have to open this up, right, and you see the set point right now is also grayed out. because I have declared it now, so to say, as an optional parameter. Right? There you go. You're finishing your shift and going home. I don't have fun without you. We're not having fun, we're learning. No one is having fun here. Yeah. Yeah, as Kai says, like things are usually restricted, but depending on the library, depending on what you're doing. As I said, there are more things that are restrictive, but that's the general process here. Okay. Now I do have my Hega process control block in the global library. One more thing. And now I've been talking. Hey, logical controls. Hi, how are you doing? And now I've been talking for almost an hour. Damn it. I wanted to. We can't finish the PID today. Oh, God. We'll see about it. We'll see. But I'm having too much fun. We're learning, right? Libraries. Very important stuff. Actually, really important. Now we talked about master copies here. There's master copies. And on the top in the project library, we also had master copies. Right? But I also said there's types. Now, types is where things get interesting. Master copy is pretty clear. You see, maybe I have now changed this block, which I actually have because I've made the set point here as a I hit the set point and I have a predefined actual parameter. Right? So let's assume I have changed the block itself, which I have. Right? Now the master copy here, damn it, still the same thing. So what I have to do to get the updated block is I have to delete this from the library and I have to grab the block new from my current project. Damn it. Right? This doesn't feel right. That is what you have types for. Can you make a change to the library? Hey, Dane. Dane, is that a question? You didn't put a question mark because that is exactly it. Dane just asked, can you make a change to a library and it automatically makes the change across the board? That's what a type is. That is 100% what a type is. So instead of having my process control block here as a master copy, I could also pop this into the types, right? And you see, I will no, it has to be a project library type here first. Well, it has to go through the project library if I remember correctly. Yes. Now, project library type, you will see has a version. Ooh, that is fancy. Define the properties for the new type. The selected object will be stored as a new type in the library. Specify the version, author, and comment for this. Whew. Right. Now, you see the block Hega process control exists in the default version 0.01. Right? Now, that's this one. And you can also see right now this block here has a little triangle there. This little triangle indicates that it is currently looking at a type. And a type can change. A type has versions, right? So if I go on my type here, I can go right mouse button and I can go edit type. And I will need to go in here, select the test environment for the type. Okay. And there I go. I am now inside of the block itself, which is not this block here on the left side. We're looking at the type in the library. Now, this could be also in a global library across different projects. Right? And you see, this object is connected with the type in the library and is currently in the test state. Right? Now, I can make a change here. In my block, maybe I want to make a change. Let's do it. Right? Let's do it. For example, I just realized that the min and max values I want as variable inputs. So make a guess. Are those real values? Yeah. Min and max. Those are now real inputs. Right? And I want them to have a default value of 0.0, generally speaking, and of 300.0, so that we have our values here. Now I'm going to use those min and max values. Boop, boop. And I will define them. We just had that, right? I will also define those two as they will hide if they are not connected. That's perfectly fine. Now we're actually making a good block. Right? Min and max. Wherever I have 0 and 300, I'm going to replace this with min and max. There we go. I think that is it. No, for the maximum error, right? God, I want to talk about so many other topics, and now I'm stuck with this. But that's fine. I'm having fun. And you see min and max. We have used min and max so many times. Oh God! And now we almost have a good program soon. Those, by the way, there should be constants, but it doesn't matter. Right? Now we have those as in and outputs. Right? Hey Richmond, I'm one of the best PLC instructors so far. Thank you very much. Do I have a website? I haven't been on there in a very long time, so not really. Sorry. Yeah. Now, what I've created now is a change to my type. Right? So what I can do is release this version. I'm going to click on the version, and here it says, hey, this is now 0.02. Okay. Now, this block now realizes, hey, I am not okay anymore. I have to be updated. So I can go on my, and this would be also available through different projects, right? Now, this block was updated somewhere on a server. So what the server can do is push this into the project, right? By updating this in the project here, right? This should be updated in the project, and I can see, hey, please, whoops, what did I do now? That was not the correct thing. This should, oh no, this will just update the type here in the thing. Set do not use identifier. It can definitely update. Do I have to update here? Go to type, open, edit. Something has changed. Update here. I have to update some. Update at the block itself. Yeah. So you will see that this block has now been updated. There is also an auto update all across the whole project, which I don't know where it is right now, but it is available. And you see every change that I do in this library block now, which could also, I can pop this library block in my types here. Right? This could be a block that is now available all across the board here. Right? This could be in another project. The other project changes this block. My project here realizes there is a new version of the block, and I can then update my block here in my project. Yeah. This is great. And that's what a type is, right? A type is something that gets updated throughout the years or throughout the time. It doesn't matter what time frame. There we go. Good. Fun stuff. Really powerful, really fun stuff. Hey, Firozen. Amazing work. Thank you very much. God. We strayed off so far from what I wanted to do. Why? Great question. Keep the questions coming. Right? Keep the questions coming. I love to answer them. And you see, this is cool stuff, right? This is a cool feature. This is great. It is important as well. So we are on the right track. We're here for learning. Right? Let's get back on the track with PID. Logical controls, the thing is, if you recompile your project, there are many settings that you can have when recompiling the project. Right? You can have it so that all blocks get automatically readjusted. So there are different reactions on when it is read. So let's not stray into that too much now. It's not like we're running out of Tuesdays, Greggy. oh goodness, you're right. But look at the topic list. Look at this. How will I ever get this? This is growing. It's the opposite of what we need. Oh no. Good. But you are right. We are not running out of Tuesdays. As long as I'm having fun, this is good. There we go. You see, this is now a semi-decent. It's not a good block yet. And you see, as I said, this now has standard parameters with it. They are hidden. Like this is good stuff. So now if our tank, for example, here would go to 400, right, I could now change this here. Now we have a very flexible cool block. There we go. Okay. Now, I think though the main problem here was, and I will now make this a master copy. I'm not going to use the type right now because I would maybe mess up some things. Right? So I want to have this as a master copy. Good. Now, I'm saving this. Don't forget to always save your library as well if you make changes. There's a save library button. Now, this project is done, right? I don't need this actually. This is now done. This is so last Tuesday. Now, as I said, we also need the other project, which is, I think, oh, I don't have it here. So, but I have it on my desktop, I think. So let's see what's on my desktop, the Factory.io template. Yeah. So that's the second project, right? That's the second project that we wanted to merge. And all that I will just do from this project now is I'm going to grab the PLC and I'm going to take the PLC and put it into my master copies. Right? And I'm going to delete it again because I want this to have a great name. Factory.io template. This is my Factory.io template that I can now use in any project. This is, by the way, this is how Factory.io should have done it. If you ask me, they don't. But it's a different story. Different people do different things. Now this template I can use in any project. So whenever I now want to connect from TIA portal or from PLC sim to Factory.io, I can use this PLC. And inside of the PLC, I can, of course, use, for example, this function. That's what we will do. Now, this is good. This project, I'm also done with this project. Right? And now for today's project, after 1 hour, 5 minutes, finally, new project. Don't save that on the desktop. Please save this in Tier Tuesdays. And let's name that Tier Tuesday and the today's date, 2025, 11/25. I will probably not finish this today. No one needs to know. Arun asks if I can make a course on PCS7. I will not right now. I could. I know how to use PCS7, and it's a cool software. I knew how to use PCS7 before TIA Portal was there. So I've used it as an engine actually in industry. The problem that I have with PCS7 is it is way bigger, and also licensing would be a lot. So I don't have the resources right now to do it. I can use it, but I'm not gonna make a course right now at least. So okay, so inside of the TI Tuesday of the new project here, we can now use the Factory.io template. Gonna pop that in there. And inside of the Factory.io template, I can simply just grab my block that we have, the HICA process control, pop that in there, done. Ain't that perfect? Now in the main block here, of course, I can take the process block, pop that in here, give it a data block. There we go. I just need to connect the correct in and outputs, the ones that we don't have yet in the project. So what do I have to do? I need to import them. And there is actually a tag table that I would need to. So I need to import the tags from this project here, which I will now export. So there's nothing really crazy about this. There. And I'm just going to import those into TIA that I just exported. I think I already have them, but on my desktop, but whatever. So those tags I will now import. I will press on the import button, and then they are also part of the program. And I now just need to reconnect, or connect whatever I want to control here. Now this is already a decent block. It's not good. I would still change a couple of things, but it's okay-ish. I want to import. And import. This is always so funny that you just see my desktop here. Lagerhaus. I love German. German is a great language. I already had this last week, yeah. Okay. And now this is imported, right? And now this is in a completely different context, right? In a completely different project, on a different PLC, but nevertheless, I can just grab the tags that we have in this project now and just connect them to my block. That's why I have a standardized block. where we have the level meter, which is our input. We have the set point, which is our set point. And we do have the fill valve, which is our fill valve output. Now, one more thing that is that we need to do for Factory IO right now is those outputs have to exist in the hardware. So I will very quickly add a hardware module that has them. So those have to exist here. I'm going to add an AIAO. Whoops, that didn't hit. So this AIAO, or AQ, whatever we want to call it, has to have those addresses, which is input byte 30 to 38. Why is that 37? Oh, we need one more, damn it. So another one. So this one has to start at 38. They have to exist in the hardware or the table would not be updated. Different topic. I might at some day get in there, but of course it has to exist in the hardware. The same with our outputs here. Output byte 30 and goes to 33. Discharge valve. The rest we don't really need, so I will still connect it. It doesn't matter. Nah, we don't need that. We're not using it, so I'm not going to connect it. So now all of this. Hey, boss, the teacher is back. It's been a month already. Yes. Now this Factory IO template thing here, I will rename the PLC to PLC PID controller, and let's see if we can finish it. Because now I will get into programming and I will try to do some stuff there. Okay. Now with this, right, let's download this and see if our controller still works or if I have broken something. We will start now PLC sim, of course. Yes. Oh, I have to set the project so that I am allowed to simulate. So not going in detail there, but we have to turn it on. Yes, I know PLC sim. Baugruppe. Yes, Michael. Yes. German is very precise when it comes to language, when it comes to words, especially technical words. There's some problem with the compilation here. What is my problem? Oh, the password. Yeah, okay, that's no problem. Just the safety settings here. I will turn this off. Do I need to create a user? What's the PLC version? What's the firmware? Hello, give me the firmware. The firmware is 4. Fuck off, sorry. But the firmware is version 4.0. If you have a version 4.0 firmware version PLC, the security settings, here the access control settings, oh, they're turned off. I think I still need to, and I will make sure, I will just do this to make sure it works. I have to, here in my security settings for the project, not the PLC, for the project, I will have to guarantee that someone can program the PLC, is allowed to, which I will give the anonymous user here, which is every user without a password, without a login, has all the access rights right now. I just don't want to mess around with user settings, that's why. Right now, I'm just going to give every user the user rights. And now I can download, hopefully. That was just a side topic. Let's not go on too many side tangents right now. And I can start this. There we go. Last thing, this PLC sim now to connect to Factory IO. I don't know why, but it needs a specific sequence. Turning things on or off. I already had this last week, so I'm not going to go in there again. Don't know how it works, don't know what it does. I just have to press on yes, connect. I literally do not know what it is. Happens to me as well, of course. Good, okay. Hurry up. Where is Factory IO? Factory IO should now be able to connect if I select the correct version here, TI version 20. If I click on connect, it should connect. There should be a green check mark there soon. Perfect. Green check mark, program is running. So now if I put in a set point, the program should be running. The one thing that I will still add right now is my trace from the last time, and then we can finally continue. We have talked way more about libraries now and about versioning code, which is good, right? We learned something, so I hope it didn't bore you too much. but we didn't get into the topic that I had on my agenda. Wait, no, wait. In my agenda, right? Smalltalk is done, right? Smalltalk, good. Merging two projects, good as well. Okay, I had this on the agenda, so we have 2 topics covered. Officially, good. Whew, that was close. So now what I want to monitor is the 3 things. Right? I want to monitor the input, I want to monitor the set point, and I want to monitor the output. There we go. You missed all the library talk? Ah, no. Yeah, you got the recording there. So that's what I want to monitor. And from the last time, we kind of still know the settings. Record events of technology objects. That's new. Fascinating. Oh, God. One thing, not talking about this, but this is our interrupt. Where is it? Cyclic interrupt. Interrupt. And let's make that 10 milliseconds. Every 10 milliseconds, this interrupt will turn on, which is... Now it's 10 milliseconds. Yeah. Yes. No, I don't need to do anything with this. And we just want to have the interrupt as our cycle, so I want to record every 10 milliseconds, that is okay. I want to record, I don't know, maybe a minute, there we go. I want to monitor without triggering right now, sure, no, I want to trigger on our tag as soon as our input set point, as soon as our set point goes within a range between, I think we had like 200, between 200 and 100. That doesn't matter. Like all of this, 0. I hate the 0.0, by the way. 0.0. Most languages do that automatically. Maybe there's a setting where I can change it. And I want to have a pre-trigger of a second. I want to save all of this. Let's make that 10 recordings. Doesn't matter. I want to overwrite the oldest one. Sure, why not? There we go. Could damage everything. Download. Done. I still need to download the PLC. Now, this was fast. This is usually the speed that this is usually my speed, right? I just go for it, chuck, done. Yeah. I just made this to test if everything works, right? Huh? Oh no, this is the thing. Good, okay. I thought this is scaled strangely. So now scaling group 1, and the output, sure, scaling group 1. So I want to have all of those in the same view. That is perfect. I want to activate the recording. Right now everything is 0, so I want the minimum scale from 0 to, let's say, 300. There we go. Perfect. Now, and that's where we left off last time. God, I get lost in random, quotation marks, random stuff. It wasn't random, but still, I get lost in stuff too much. So now if I should be able to set the set point and our system should be able to react, right? Why is that so tiny? Huh? That doesn't look... I mean, this looks correct, but why is it between... Oh, between 0 and 10. Yeah, sure. Yeah, I got it. My bad. And 10. That's better. Okay. Oh, boop. And this looks okay, right? This looks okay. Yeah, our block still works. That's all I wanted to confirm. Now, when I watched the part of the recording, I realized that I can zoom in, right? Yeah. I didn't see that last time. So this is now, you see there's little gaps in there. So we, PLC Sim now is a little bit slower than PLC Sim Advanced, actually, I think. Nevertheless, it works. Why is the input above the set point? The input is above the set point. That is... And now I hope I didn't break the block. I didn't check the block if everything is okay. Was everything okay in the block? Probably is. Oh, I have the gain as a constant of 20 here. That might be it. Now, what do we do? Now we could go offline. The proportional gain I now don't want as a constant. I actually want to have this as another in to the block. Right? Now, the default value should not be 20. The default value should maybe be 1.0. So, good, okay. Now, this should be accessible. Now, just a second here. Sorry, I want to confirm that everything is okay. Let's see. Am I so Selimk asks if I'm a co-developer of Factory IO. No, I am not. They once got in contact with me and wanted to cooperate, but I never answered. I'm very rude sometimes. But I haven't. No. Should maybe, but no. Is this just still the P controller? Yes. No. The I and D is actually what I wanted to do mainly now. Right? So we have a proportional gain, and we also want to have this integrational and the derivative part. And that is actually the main topic I wanted to get in today, and now it's been 1.5 hours, but that's okay. Right? So if we have a proportional gain, we also have an integrational part, the I and the D. Let's just go with PI and D. Perfect there. Right? PI and D. Now all of those. Now we really have. I'm going to make like this is a nice block now. And all of those are optional parameters. I'm going to hide them if they are not being used. There we go. Perfect. Now I need to, of course, update the block call. There we go. Okay, now for the integrational and derivative part, I kind of wanted to, I have stuff prepared, who would have guessed? Now, for the integrational and derivative parts here, we would, and I unfortunately don't have credits, but I googled I googled it to have a nice overview. But this was a nice one that came out like after a minute of googling. Sorry that I just stole the picture, which is not nice of me. There should be a reference. Wait, let me go in my browser settings here. Control H. Where was this? I can never ever find this. Wait, PID. I'm gonna search PID. Oh, it was one of those. No, I can't. I can't because this would be like it. I got it from like the AI of Google, the result, and I can never get the same Google result. So I stole it now. It's from DigiKey. Oh, it says there. It's from DigiKey. Now you see up here all of these parts, right? We would still need one more thing, and that is actually important right now. And I will not go into the integration and derivative part too much now because I kind of can't. Right? Because of timing. I want to finish this today, so I will kind of skip over them right now. What I would need to add right now into my program would be Ki and Kd. We have those already. There would be one more very important factor, which is the time interval. Right now, our P factor, our proportional gain did not consider time differences. Now, an integrational part needs time because it needs to sum up over time how big was the error. So every time interval. How will I draw this? Let me draw this. And let me actually get back into my trace here, and inside of the trace, I don't want those values anymore. I actually want the scaled ones from last time. Those were much nicer. Those were much nicer. Just a sec. Input scaled, percentage, set point scaled, and the output can also go in here. I don't care about the output. Okay. Why is everything not updated? 1 second. I made differences and I don't... I added the P and I, the IND, which I'm not using. That's okay. Just 1 second. So now, that's why it wasn't pretty. And this is just me rambling here for a minute. Give me a minute to sort my thoughts. Scaling group 1, scaling group 1. I don't care about the output. Minimum scale is 0, 0, and then 300. There we go. There we go. Okay, perfect. And now I want to have the nice graph from the last time that I really liked. So let's go to 0 and let's go back to 150-ish. There we go. Now this time it looks nicer. Yes, the sampling time is important. Exactly. Wait 1 second there. You have a question for integer of the PID compact. I have a problem with not resetting the integer sum, and when regulator starts regulate, it remembers last regulation integer part and gives me almost 100%. Artico has a question, and I will now talk about the integral part here a bit. There it is essential. There is a very, very essential thing. And I will get to exactly that. And Pranav with the sampling time, 100% also an important topic. I will also get to that. So you see right now, this is kind of summing up things. So summing up. So we're getting closer, right? The green thing here is the output. Wait a second. Can I stop this? Deactivate and then it will give me the graph, yeah. So the output is getting closer. The closer we are getting to our set point, of course the smaller our output will be. That is what the P part does. Now the integrational part, and that's why I did this now. The integrational part is the following, and I'm gonna draw this with my favorite color, yellow. No, yellow is hard to see. Purple, green. No, violet. Brown, beige, hellbrown, with hellbrown. So now the P part here, the green part, that is a pure P controller right now. It reacts always on the difference. If the difference gets smaller, like it does right here, right? This, the difference here. So this difference results in this height. Now, if the difference gets smaller, the height gets smaller as well. Then we have the integrational factor in between, so, but that's it. Like, it is directly proportional. Now, with the integrational part, it is different. The integrational part will also start at 0, and as soon as we see a difference here, it is going to calculate, of course. It is going to calculate, and it does not calculate all the time. Now, with the integrational part, it would start here, right? At the first place, this is where the integrational part would start. And now we don't need the P part down here. We don't need. You don't need to look at that anymore, right? Now, in the first place, right, integrational part will be 0. Now, what we do is we don't calculate everything all the time. We look at maybe, let's make this is 5 seconds, so this is approximately 1 second. This is approximately 1 second here, right? So this is every 1 second there is a new, let's say we sample every second. So in the first place here, what is going to happen at this moment where we want to calculate, at this moment, until here our integrational part was 0. Now what this will look at now, our calculation is, how much was down here? How much is down there? That is what the integrational part will look at. And then afterwards, right, in the second place here, this integrational part, let's say this is 17, whatever that is, it's just a value, right? Let's say this is 17, however much this is in there, 17. In the next time here, for the next second, the integrational part is going to react with the number 17. which might be the output is on for like 2% or so. Doesn't matter, with the number 17. Right? It will then, at the next moment, look under the graph again here, and it will look at the, of course, at the integral here. And it will realize, hey, there is more I have to add to the 17. This time it might be 14. So it will do 17 plus 14. It will add on top of this. So this is now 31. So the integrational part is now acting stronger. It's now acting with a value of 31. In the next moment, it is going to look under this again. Right? And now let's assume we are way further here. Right? And you see this orange thing that I'm drawing is getting smaller and smaller. So every time we recalculate the integrational part, right, we will add on top of the sum only a little bit more. Right? So the adding up will get smaller and smaller and smaller and smaller. However, as long as we are below our set point, we will add on top and add on top. The integrational part will be stronger and stronger and stronger and stronger forever right now. Now, Arteco had the question that, like, this is called the integral sum. And let's say this is now 200 or so, whatever. Now, this integral sum will run away. Right? It will run off. Like, this will get extremely high. And at some point, like, you can never ever counteract to this again. It will become extremely strong. So a good controller will limit this number. And that's what I wanted to do in the first place. But now definitely I don't have time anymore. A good controller would limit this number. A bad controller will just have this running off until infinity almost. Now, if this runs off to infinity, a lot of times, and not a lot of times, but if you are now above, if your value here would be above, if your fill level or current value is above your set point, you will slowly, of course, from this sum that you have, from the integral sum, you will now like subtract, because now it's a negative error. So you will slowly subtract, but because your integral sum has already run off like crazy, it will take ages until your integral sum is in a good area again. Right? So it will be very, very, very aggressive. Right? That is why for the integral part, we also have to find a nice value. Right? Nice limits, and also a nice integral value that it's not acting too strong. And this is stuff that I won't be able to finish now. This is just something that we hypothetically have. Yeah, unfortunately. Unfortunately, that's what we have. Yeah. There was one thing more. Oh, yes. The one more thing. It was the sampling rate. Right now, right, those orange squares that you see, they are not squares. They are currently, like, I filled the form. I filled the shape. Those shapes don't exist in technology. They don't exist in reality. So what we have to do is, when we take one sample, right? When we take one sample here, we will not make a perfect square, right, in our sample. We will not fill the shape perfectly. We will have slight sampling errors. Right? That is why it is important. So it's a multiplication now. It's the value, the error value multiplied by the time. Right? And I'm explaining this so bad because I'm now rushing it. Sorry, but what we need, and that's this here. Right? The error itself, the value itself, is just one level. Right? We now need to think in time as well, which is the second dimension. Right? So we have a square that we add onto. We will have a total area. We won't have a line now. The integral part is not a line. The integral part is an area. Right? The area is the multiplication of all errors that we had with all intervals that we had. Sorry, this is now, don't need to understand this class. We don't have a class right now, but still, this is not going to be on the test. Yeah, Teiko, one solution to have this, to get this to 0, is putting it into manual mode. Yes. Unfortunately for Siemens stuff, right? For Siemens stuff, sometimes you have to do that. But I can show you another way because now I want to enter. I want to enter. Let's actually add this. Let's quickly add this, and then let's enter the PID compact area because then everything will be pre-done. So this, all the theory out the window, right? You don't need that. Now I will still add this to my Hega process control block so that we have it. Like the integrational, this one here, is not going to affect anything right now, right? Because integrating this mathematically would now take some like effort. What we will just have is this without it, right? And the sampling rate and everything. Oh no, we would still need the sample rate. No, I can't. I cannot implement this really in the program because we would need the sampling rate. We would need time. Which is a constant. It's so practically this won't be good, right? For the integration part or integral part, right? You would say integral part in English. It's integral in German. Like for the integral part, right? What we simply do actually, and I will have, and this is the what Arteco talks about. We will have a static variable here, and this is the integral sum. The integral sum is every time we get into this block, right, which is right now approximately, and that's why it's not perfect. It is just an approximation right now. Every time we do the calculation, I could easily fix this, but time. Every time we get in here, we will add to the integral sum. We will add the current error. Where the current error I have calculated, I already have calculated this, and this will be our new integral sum. Logical control, I could just take the interrupt here, the 10 milliseconds, That's what I thought about, like when I said, hey, I could easily fix this now, which I will do. It will slow down, it doesn't matter, it's fine. Just 1 second. I will take my block, and now my block here, my calculation will only happen every 10 milliseconds, which will break the P part as well, right? Now this controller only happens every 10 milliseconds, and that is actually important. This is the sampling rate, right? Now my calculation happens every 10 milliseconds, sample rate. Just put it into second block. Yes, Jason. Thank you very much, Jason, and hi. I don't know if I already said hi. I do have this, you are completely correct, and this is now my sampling rate. Right. There we go. Now, the problem that I still have with the sampling rate, which is why I said I'm not going to implement this now 100% correctly. And I'm not supposed to, because we do have the PID compact block, which I want to implement, right? Now, for the integral sum, right, we would need to, and that's why the screenshot that I had here with the formula, this formula is actually hiding in the interval and error calculation. Right? We need those values need to be calculated in there. It's not that easy to actually get to the result there perfectly. So I'm gonna have this. We will just see this running off a little bit, right? And that's what I want to. God, will I do that again? An hour and a half. Like the last 5 minutes, I was just like considering oh god, I'm too slow now. Now let's go step by step. Let's take a little bit of speed out of this, right? And by the way, hey Woo, hey there. Let's take some speed out of this. So this integral sum right now, if I monitor my block, you will see this error pops up, right? The specified call environment is invalid. I know, testing, change the call environment and say, yes, this is the one. Thank you very much. Now the integral sum, what we will see. Perfect. Yeah, logical controls. We kind of need time as the real value here. Like, because the this is now simplified. Taking a step back. Sorry, I need to sometimes slow down. Yeah, almost 2 hours again. Um, there are different ways to interpret the integrational part, like PID, right? There are many different ways of interpreting PID. The most simple way, that is not really perfect actually, is this way here. Just multiplying the integral part with some factor. This factor right now, right? What is this factor? Is it time? Is it a value? What is this? Usually what you would have is that the ki would be an integrational time factor. This time factor would include sampling rate and other things. So we would we would have to consider this a little bit there, right? So in the simplest way, we will have this. So we don't actually need the like time factor too much. All things aboard, right? This is now. I don't want to enter too much in this area. We will just implement the PID block soon, and there it is much easier with the PID block in a moment. Okay, let's see the integral sum though. That's what we want to look at. The integral sum here is now the factor that we want to look at. Right now we are. Error? Why is the? Do we have an error of 0 right now? Is that possible? Are you kidding me? Is our controller perfect or what? Where's the error calculation? Error calculation. Do I have error calculation? There. The error currently is 0. Are you kidding me? How did we get to... How is the system by chance perfectly scaled right now? The smaller the rate, the more accurate, yes. But let's see. Yeah, okay. Now the error here is now negative, right? What the integrational part or the integral part will do is you see, and it is already running off like crazy, right? This integral part is now going crazy, and it will drop more and more, because every time now it will, of course, subtract the error. Oh, you know why the error was perfect? Because the discharge valve, we have a perfectly controlled system because there's no error value in this. There's no disturbance. A very important part, actually. That's why it was perfect. I was wondering there. Yeah. Now, the problem with this integral sum is you see it runs away. It runs away like crazy. So what is inside? And that's what I'm saying, right? What is inside of the what should be inside of the integral part here should actually also include limitation. It should look at times. It should look at data types as well, which right now it's just running away. Like, what is this even, right? I could use this integral sum now though with a factor, and this factor will be crazy small, insanely small. And Arteco, yes, there are controllers that are related, that are relating integral part and proportional part. Depends on how you build your controller. There's different types. This is not a masterclass about PID. We're just in PLCs. We're just in TI Portal. But you see, right now, this error is actually getting smaller. So every time we add something on the sum now, that's why I'm resetting this. Can I not? Is the do I have to go into the data block to reset it? Are you kidding me? This does looking like a cool thing. The integral sum, yeah, I can. Let's set that to 0. Right? And you see now it's still running off, but not as fast anymore. Right? So the closer we are to the error, the slower this number is going to go down in this case, or up, depends on what we have. And it should actually be going up. I have it the wrong way there. So it should actually be the error minus. No, this is correct. This is correct. The error no, it's correct. Everything good. Let's see. Sorry, coming back to the chat there for a second. When using a compactor, it must be a cyclic time as the sampling time. Yes, logical controls. When you use the PID compact, which I will now switch over to in a second, you want to you have to set the cycle time. I will get there in a second. There is actually some important factors, so I will go half an hour longer today again, unfortunately. Now the last thing that I wanted to do actually is here. Right? Now what we need to do is we need to have a multiplication. This integral sum, right, has to be multiplied with our with the factor that we have, with this integral factor that we have. And this right now, the integral factor has to be extremely small because we're not considering any of the other parts that I talked about. And this will be our static value here. This will be our integral action, I would call this. This integral action is now here, this part, the plus part, and the output will now be an like an accumulation of the p part that we have calculated this far and the integral part. Should be. Sorry, I'll be with the chat in a second there again. The problem now is that this integrational part, that the main problem that I have right now with this integrational part has to be insanely small. Talking about, I don't know, something along those lines, 0.00001. Something along those lines. It has to be crazy small for this integral part to not run away. Now, this considers, for example, milliseconds, right? We would consider, it would have to consider milliseconds, for example. God, why did I talk so much about libraries? Shouldn't have. And now the valve opening, right, is not just my temp p scaled, right? I will call this also temp. Is this temp? This can be temporary, right? Do I have it in static? This should be temporary. If we want to consider also optimizing the memory here. Temp. Now, all of this not too important. I'll get back to it in a second here. Temporary integral action. Now the total action should be the sum, and now I will have to subtract because it is negative. Oh God, that was so stupid. How did I calculate the error? That is wrong. The error is the wrong way around. God, I made it. Now I start making mistakes because I'm rushing it. What I know that I have to now subtract the integral part because we just saw it run off very, very negative. Right. And this I will save in temporary. All of this, as I said, this is just for me right now so that I have this right, that I have finished this, but right now you don't take 5 minutes break. Class, take 5 minutes break. Or maybe a minute because this is already done. So not perfect, absolutely not perfect right now. Right, 100% bad. Like this was bad style now because I had to rush this. But that's again okay because we will take the pre-made block in a second here. And my integral sum, that is a big problem here, for example. My integral sum still has something. I reset all of the system, everything is gone, but my integral sum still has, like from the last time, I have to reset this manually now because it has run off already. Now this won't be perfect, and the factor, as I said, the integrational factor there is definitely and 100% not perfect. That's what it is. Sometimes I have to also look at this. I mean, this looks pretty impressive, but percentage level. Where is my integral sum there? Oh, it is acting right now. Oh, God. This is running away. I've got, I have zero control over this now. Fuck. Oh no, it's running away. I would have to stop the PLC from acting. It's okay. Mm-hmm. So you see right now, because I can't reset, this is actually exactly the problem that Arteco had. And sorry, I'll be with the chat in a second there again. This is actually the problem that Arteco had. Right now, the integral sum still has a value from the last time around. Right? I reset the system and everything. It has no set point right now. It's still acting. Like the integral part is still acting. It I have something the wrong way around, but we can we can learn from it. Why is it? Why is? And now I really So the error is negative. Why would the error be negative? So we are missing 2.9. That is okay. Why is my? As I said, a minute here. Oh no, it's actually correct. It is correct what it's doing because it is letting something in, but the set point is 0 and it's counteract. It's so stupid right now. No, the integral part is definitely too small. That is correct. Wait. No, I was incorrect. This needs to be an addition. This needs to add up. I don't know. The set point is at 0. I know. Wait. Okay. 1 minute. Give me no 2 minutes. 2 minutes. I will be in absolute silence because now I will. So I'm starting a timer. 2 minutes because I need to analyze what's going on because right now with streaming and me talking and so of course this is complex. So 2 minutes I will concentrate and try to find the error there. Sorry. try to also do the same in your head. 2 minutes starting now. I'll just fix it. I don't care about it. I will just fix it. Oh, this is now very bad. Right? I am just going to invert the whole thing. Who cares? There we go. This is just like one of those. Oh yeah, perfect. Talk to each other. Let me just test if this works now. I probably broke everything now. Can happen. There we go. Set point is 0. Let's reset the whole thing. And now the problem really is. Yeah, you see this is running. This is running away. This is okay. Why is it still? Input scale, set point scale, so the input is higher. There we go. There's a timer. Oh goodness. -10 outside. Oh goodness. It's not that cold here, fortunately, yet. Slowly getting out of the system, that's okay. And the 2 minutes were a lie, by the way. Give me one more. This should be easy, but I got something messed up right now. Yeah, I know. I always have an error at the start, but resetting both tools is quite difficult. And you know what? It doesn't matter too much. I might fix it, but that will be off stream because I still want to spend like the last minutes that we have doing something useful and not me just troubleshooting my own stuff when my head is not in it anyway. That's a thing here. Let me just do one last testy thingy. I want to have the iPod much stronger, right? Because if it is stronger, it's easier for me to test the thing. So the error is getting bigger. Why is it getting bigger? Because the integral part was still doing stuff. Now the integral part should be doing actually exactly the opposite of what it's doing right now. Oh, you're right, logical controls. I could use, there's a bit that I could use to turn this on or off, depending on what I need. There is a bit that Factory.io gives me called Factory.io running, right? Yeah. I could use this, but no, we're not concentrating on this now. So the integral action right now, this kind of looks decent. The input is still there, the error is still there, so right now it's still getting bigger by 4 approximately per second, per 10 milliseconds. So this part here is getting bigger by 4 per millisecond, which is 400 per second-ish. So this is going, this is good. This is going the right way. This is completely messed up, whatever I have done there. But this is going kind of okay. Now what I need to do, maybe it works. I'll put this to 0. And you see, like, it is slowing down because there is still a little bit is still inside the tank. It's not 0.00, right? There is still something, like it is 0.0, but not 0.000000000. Now it would be, right? And now it should not move anymore. Perfect, okay. Thank you for giving me like my 5 minutes that I needed here. It's not perfect now. I completely messed up the calculation, and so it should probably work, kind of. But the integral sum part here, the integral part will be very, very strong. So let me actually make it not as strong anymore. That might still be too strong, don't know. But maybe now the integral part will not run away without any issue. Right now it will not, not run off. Right? Now if I set the set point to something, let's see the integral part will slowly get stronger, and that's what it's supposed to. I mean, this value is kind of okay. This rise is kind of okay. So it will get stronger. But the closer we get to the set point, the smaller the growth of this will be. Now all of this, not perfect. But last thing that I still want to do is I want to put this in a trace to actually see what's going on. Right? So I want to have here the proportional part. So the not the proportional part. I want to have the integral sum in here, which won't be great. As I said, I messed up there quite a bit. Nevertheless, we should be able to see the integral sum. Now, all of this is gonna look funny because now I want to reset. The problem is I have to reset at the same time in 2 different places. I could use this reset. I could use, like, I could program now a little bit to make this automatically. However, not gonna happen. So this has to go to 0. And very fast, I have to also reset this. And then it will kind of stay. Okay. God damn it. So that's okay. And now when we monitor, and now finally this is gonna be much nicer now. Not perfect, but we can see the result that I want to see. What's this? Delete trace from the device? No. Stop it, and I will now click recording. And now when I set the set point, we will be able to see that the integral sum is going down because I have it, like, I have everything flipped, right? But we should be able to see that the integral sum. Why did I flip? This is so. I'm like a beginner right now. Like my logic here. Sorry. It's like a beginner's logic. I don't. My brain doesn't brain right now. But this integral sum, right, is slowly slowing down, right? And as soon as we have an overshoot, which damn it, right now we should have an overshoot, which I should be able to see set point and input scale. Damn it. Can I put them on the same scale, please? Set point and input scale, yes. Same input group. Right. And right now, this now looks nice. Right? It's the live stream. No, it was me just. I don't have much pressure when I live stream. It's me just, my brain not braining. Right? And right now, oh, there, 100%. We actually see everything acting like the integrational sum. It's not even a very bad value, right? But you see, we have this overshoot that is very, very long. Right? The overshoot is really speaking about time, very long. Because the integral sum, it goes up and it will only slowly subtract again. Right? So we don't have the correct value. It's working. Yes, Jason, it is working. It is correct. The problem right now would be that this value that we have might be too fast, might be too slow. In our case right now, it is too aggressive, right? So we would need to slow it down more. As I said, this needs to be a very, very low value, right? Whoops. Which is not, this is not good value right now. This doesn't make much sense. But the theory there is correct, right? Now, if I download again, and all of this should be variables as well. If I download, if I put my set point here to 0, if I reset the simulation, if I now also reset my integrational sum here, my integral sum, I now should actually be able to see a nicer graph now. And now this will finally have a kind of nice look to it. Let's see. Right? If it's working, don't touch it. This is not working. I mean, it is working, but it's not good. Now, if I put the set point, let's say somewhere in the center there again, you will see that the integral sum, that's the one that is important for us right now. Right? This is the one, and it needs some time and then we can see it. The proportional part, for whatever reason, was negative. What? How? Oh, it's the output, right? The output is the sum of proportional and integral part. In the beginning here, you see that the output made a jump. This jump in the beginning was our proportional part. The proportional part directly acted on the error. Right? Now, the second thing that we can see is that now, instead of having like a straight line, we now start having a curve. Now, the integral sum will slowly curve this, the little steady error? How's it called? Der stehende Fehler. There's always, if you just, not always, but if you just have a P controller, you will have like a steady error that is there, that persists. Now this steady error that we can see here, if we would only have a pure P controller, the difference between the set point and our current value, it would persist forever because the P part, the steady state, thank you, yes, the steady state error. Now, because the P part won't act stronger, right? The integral part, right now, is still acting. So we are slowly, the integral part is getting stronger, as we can still see. It's right now minus 750,000, whatever that is, right? It's getting stronger. So it is slowly approaching there. And I would now say, now it's too small. So we would have to get a better value. And I will do 2 fixes here that will help us actually with seeing everything and that I'm explaining here. I don't want the integral sum. I actually right now want the... Can I? 1 second. And now I'm back in this topic. I want to go in there. I want the temp integral action. Now the temp integral action, though, that's the one I want to monitor. And now it is a temporary variable. Now it has to be a static again because I want to put this in my trace. Damn it. And there we will see a nicer value. Now all of this is not by accident. This was all definitely planned by me, and I didn't make any error. I just wanted to emphasize how difficult it is to create your own controller and how difficult it can be to have your math correct. Even though this isn't too difficult, still can happen that there are some difficulties in there. Of course, everything here was by design. Which variable did I say? Oh, I have to recompile. So this was by design, right? I just wanted to show you, and now we will make the easy solution in a second here. So this should still be... yeah, I do the mistakes so that you don't. This should be the integral action, right? That's the one that I said. And I will also have the... I will also put on the other one, the proportional action, so that we see those in relation to another. So I will also have this as not temporary. Currently is temp p scaled. Yeah. I will rename this in p action. Paction. Proportional action. There we go. So by the way, today we started with libraries, and now we are definitely at parts that I didn't want to enter too much, but now we are. Proportional action. I do apologize, but you're still here, so I hope you enjoy seeing me fail. Which I think right now I might have fixed it all. Not perfectly, but it is okay-ish. Proportional action. We don't really need the output anymore because the output is now like the sum of both. Let's put that in there. Good. Can I display 5 variables at the... Oh god, like the scaling groups. Of course, this is scaling group 1 now. This is scaling group 2. Now, the minimum scale on this is 0 to 300. And the other part is, I don't know. What did I set those to? What is this output here? A real. 0 to 10? Was it 0 to 10? We'll see. We'll see when we go live. Okay, there we go. Go live. Yep. Yeah, Trace, definitely. And I do apologize that I didn't read the chat in like a hot minute there. But I kind of was concentrating. So let's see. Waiting for the trigger. Let me reset everything here. Let me go back in there and also reset the sum. And now really annoying is that I have to reset the integral sum here like manually every time. I literally have to. Why is that happening? Why is it still running off? Why would that be? Hello? Stop it. This is okay. This is okay. Ah, there was still something leaking in there. There we go. Yeah. Why is the integral action negative? Shit. Oh, that's where the problem is. That's where the problem was. Yes. I inverted at the wrong place, but I'm not going to fix it now. Is the integral action? No, it's not Was it negative? I don't know where the error is. Okay, let's run this. Right. So the trace is tracing. Perfect. It will always show us the last minute of everything. And now let's actually yoink this on. Now this looks good. That's what we want to see, right? So what do we see? The second graph is the second one where we have purple is the integral action. Yeah. Sorry, and now I could read again. Sorry, now this would be fine again. Watching someone with experience overcoming problems is actually really, it can be, yes. Thank you very much. And you see, right, the purple part now is our integral action. And you see this goes up, right? This goes up, and you see the green part, what's what? The proportional action is the brown part, right? That's what we had, and the green part is the sum of both. And you see in before with a pure P controller, the green part was exactly at the brown part. That's what they were the same. And now we add on top the pink part or whatever color that is, and now it will automatically zoom in. This pink part, the only purpose what we have this pink part for is to get rid, or the main purpose is to get rid of the steady state error, which would have continued existing. And now, if we just wait long enough, integral part is too small. So I should just now make this bigger. And now it's tuning, right? Now we would go into tuning. This integral part is now too small. Right? I would make this bigger so that this gap closes faster. And now we could wait. I could just leave that running forever. I'm gonna read chat while the gap is closing in. Take your time. We can stand here for another hour. Hey, Mika. No, I'm not gonna. No. We're gonna make this good. Make it big. Yeah, we can. Okay, yeah. By the way, Jason, I watched your video, right? I watched you, not all of it, but I watched like the part that you sent me, and I was like, yes, I need to react on this as well. We want to see the wave. Exactly. I saw you interacting with the waves, and actually today I had plans to also react on yours, but I will still open it up like in the outro there for a bit. Right? I saw you like look at the stuff that I did there. So I want to I maybe get in there for a bit. And I saw you interact with the waves that I did. And this is not wavy now. So let's give you for the next time where you where you can at least you will get something from me to interact with, right? So this our proportional part is set to 1. That's why it's reacting so slow in the beginning. I was wondering why it does that. Does someone remember the number from last time? Is it 20 or so? Is the proportional part just 1? Do we really just need to tune? It's just 1. We just really need to tune the controller. I forgot that I didn't set it. I was wondering why it's so slow. Proportional part was something around 20, right? Integrational part might now be okay, actually. But with the proportional at 20, oh, you remember 20? We had 20, we had 40, we had different ones. But I think the last one we had was 20-ish. But I could be 40. Like those are just multiplicates. 25. Oh no. Ish. 20-ish. Can we go with 20-ish? That's fine, right? 20-ish is okay. So let's reset this whole thing here back to 0. And I will need to reset the integral part here as well. You see it ran off like crazy. We should limit this. Which I would have done, but right now we, won't. It was unstable at 50. Yeah, I know it was unstable at 50, but I don't know what it set it to in the last part there. Okay, now it's 20. Now it's going to react faster again. That's good. And let's also increase. No. Let's put the integration part to 0. Let's do the right thing. Let's do the right thing. Oh God, it's 2030 now. I wanted to. What's up, fellow automation nerds? Yeah, we're doing good. Don't watch the video once it really comes out. Don't do any rewatch there, lucid dreams. Everything is running exactly according to my plan, 100%. No errors have been made. Okay, there we go. Good. Okay. Now everything is reset. Now here comes the good part, right? This time with no proportional part, no integral part. No integral part. There you go, Jason. Right. This is for you. This is you. You have new graphs now that you can see. Sorry, I will still open your video for a minute there, but I kind of miscalculated everything here. Now, have a great day, Sam. Hi. So now with no integral part, right? And you see the P part here is quite strong. We might have a little bit of an overshoot. And also while I was watching your video, Jason, I realized that I can zoom in. I can do this, right? We can zoom in on this. So the closer we get here, the less our P part is going to react. And we do not have an overshoot here, so everything seems to be in order. This is actually nice, but however, right, very, very small. However, we do have the 100% and stop this whole thing. Right? We do have, if I zoom in, zoom, enhance. There it is. Verdammt, ich bin zu spät. Nah, you're okay. Up there. There is the replay. I will go a bit over time today. Now, you see this here. Right? This there. We don't have oscillations, right? Sorry, no oscillations this time for you, Jason, but we do have the steady state error. Do you see the difference between red and blue? The P part is not strong enough to in itself get to the blue part. We could make it overshoot over the blue part, right? And then we might provoke oscillations and so. There are different control systems where this might be fine. Like, and now it would be great if I open up your video. Wait a second. I do have it open there. Wait, opening Sam like live reaction there with freaking goddamn it. Why do I get ads? Wait a second. The waves are fun. That's why, right? Last time you had the waves. Like if our P part and I do have. No real reaction there. Sorry. Hey, that's me. I'm live. With the P part here, right? We can have this overshoot at one moment, like this smart guy here, by the way. There, you can also click here. Click on Jason and go to his channel. He is so much more intelligent than me. I realized when watching this, I'm just like making stuff up as I go. No, of course I know what I'm doing, but still. He goes in detail. He tells you about the industry perspective and everything. It was really interesting listening to this. I watched I could only watch half the video because I realized it too late, but really great stuff. Next live stream, let me know when you're on. Right? So from you, yeah, right? And your voice is much nicer than mine. I won't find the right part right now, but you see, right, with the pure P part, we can have the problem of the controller becoming unstable. Right? Sure. We can have oscillations, everything can run off, everything's bad. Now, what we want to do with the P part, and you talk about this a little bit, that we do have, you zoomed in, like I zoomed in, you tried zooming in, everyone tried zooming in, couldn't do it perfectly. Like we will have this steady state error or oscillations. Like we have to kind of choose, right? Yeah, he really, I enjoyed the video, like really great there. Unfortunately, I wanted to react, but I can't, time-wise. Next time I will. Yeah, so counteracting the steady state error. What we do is we can implement now our integral part. Let's add the integral part at very small, and the calculation there is completely off. Let's add it at a little bit stronger here. That should be fine. Now with the integral part, let's build, by the way, Jason and everyone, let's build a huge automation nerd network. That'd be fantastic. Yeah. So with the integral part now activated, let me completely redo the thing here. Perfect. Oh no, it's doing the thing, right? I have to manually, of course, manually. Boink. Yeah, don't stop. Stop it. Stop. Stop. Reset. I want to reset you. You please reset everything. Reset, please. Why does the set point increase? Gautam, very good question. Why does the set point in the beginning increase and decrease? Because that's me. 100% that's me. I do the knob here and I always overshoot a little bit and then I recorrect this there. Right? So, yeah. The overshoot of the set point, that's me. I do change the set point. 100%. So let's turn on the set point, this time with the integral action part. Unfortunately not perfect though, but there we go. Integral action is now pink. You see the integral action is acting very strong and it is adding on top. It is already twice as strong as our proportional part, which might be okay depending on what we want to achieve, but we will have a steep drop off now. Yes, you see the proportional part drops to 0. As soon as we reach the set point, it dropped to 0. We can zoom in there. This is so cool, right? I zoom in here for you. Right? At the moment we have reached, which is exactly this moment. As soon as we hit the set point, our proportional part will drop to 0. We could go into the negative. Like Jason explained in his video, that we could also go into the negative, basically getting liquid out of the tank, which I don't have here. Yeah, but we could. Right, sure, but we end at 0. So proportional part goes to 0. The problem is now that the integral part is acting too strong. So we have a very big overshoot. Right? It's a pure I right now, right? Because the proportional part doesn't do anything right now. Only when we drop below the why is it auto scaling again? Right? Only when we drop below the set point there again, we will have the proportional part again. So this is actually a nice controller right now. Unfortunately, I messed it up and took way too long. Right? But this is now quite nice. Right? We have an overshoot, but we are slowly getting there, and we will get to exactly the set point. Right? And when we are at exactly the set point, you would also, like, we will have probably some oscillations now, we will see. And now proportional part starts again. As soon as we are below, right now, the set point, the integral part will start getting smaller, sure. And the proportional part will start acting stronger again. So now we will go, yeah, we need to. That's exactly where we are. So Jason just said we need to go. We need to let it go into the negative to counter the integral. Yeah, that's kind of what I wanted to do. Now the problem is we have not tuned anything. Now what we could do is we could now find great P and I values in this case. I'm already 20 minutes over. Not gonna happen. Right? We could, right? We could. Now the integral part. You see, there's so much complexity in this already, but my calculations are so off. Now what I will do though is this PID controller here, this stupid Hager process control thing, I'm gonna push this into the library now. Right. Here we have this in the master. That's what it took like an hour to talk about. Right. In the library here, I'm going to make a folder. I'm going to call this PID control. Right. Now in this PID control, this is the start. This one just had the P. Pure P. Right. And the one that I have added now, this has also an integral part. So I'm going to pop that in there. PI. Now we would also, right, there we go. Now I will publish this somewhere. I will let you know where you can download this if you want to from the library there. If you want to, don't have to. This is kind of messed up now. Now we would need to tune all of this, right? And that would be a lot of calculation. That would be math. It would actually be fun to tune it, but not now, because also this is not 100% correct right now with the integral part. Because the integral part there's two parts missing in this, two essential parts for me. It works in theory. If this would be a class, and I would just be teaching a class like to beginners, right? To beginners. We have this now. This would be fine. We would be good. Like we would be good. This controller, it kind of works. Now, what you would usually find in industry is more precise controls, more adaptive controls, more detailed, more like what I was talking about earlier on, like the sampling rate we would integrate into this. We would limit the integral part. We would have so many more interactions possible with this. We would also have a potential P part there, the derivative part, which we don't have, right? So we could, like in a classroom, this would probably be fine right now. Not good, but fine. This value is kind of random now, though. Right? This is, what does this say? Usually, what you would have, right? Usually, what you would have, and I'll get back to the chat in a second. Sorry, I can't. Usually, what you would have is, of course, something that makes a lot of sense. And now let me do the following. The Hega process control block, delete. I've got this in the library. It's fine where it is. Right? Now what we would do instead. Right? What we would do instead. Yeah, Jason, I can I give you like wait a second. Here you can have also mod rights, I think. Can I promote you to a mod? I don't know. Yeah. Yep. Sure. There you go. So you can now also share links and stuff, I think. Congratulations, Jason. Welcome to the team. Yeah. Now, what we would do instead, my Hega process, this is messed up. I kind of want to finish this and want to improve it and want to make it good, but right now I won't, time reasons. Now, what we take instead usually, right, would be a completely pre-made controller. We're in automation. You don't design the wheel new. That's what I've been doing, kind of, right? This is completely stupid. This is completely unnecessary. Hey, now your name is Blue as well. Congratulations. Everyone else can have it as well, but I now saw Jason's channel and I saw you and everything. You got a wrench now. Everyone else that's behaving can also have mod rights at some point. But yeah. There you go. I know Jason's face, so if he does something wrong, I can find him, right? Which I won't. No, this is not a threat. I'm not gonna find you. There you go. But you have a wrench now. The wrench fits. Yeah. So what we would take, of course, is from our instructions. Here we can take a technology object. Now the PID that I was creating is just some math instructions, just some simple calculation. It was really simple. I messed up because I'm simple-minded, but like it was still very simple. PID itself and many more things are extremely complex. Right? So what we do is for very complex technology tasks that usually take its own technology, its own hardware, its own stuff, right? We do have technology objects where, for example, we can take the PID compact block, which is not just a block. It includes calculations, it includes limit values, it includes so much. So I'm going to import this now to my project here, and it will create a technology object instance. Right? Now this is, you see this here, PID compact, it's its own complex thing. Right? Now this own complex thing also uses a set point, it also has an output, it also has an input, so I can directly link the parameters that we had, which I will not take. Set point was the set point. The input is our input, 11 meter, and the output here is our output, our fill valve. Now this is everything. This is it. Oh, this is it. This is not completely it, but this is kind of it. Right? Now what I still can do with this is much more. You see there's so many optional parameters. There's so much more we can do with this. Now especially if I go in, and I might make another video about this or so, but like we'll just see that running in a second. Right? Now I went into the settings of this block. It's its own technology. Of course, if you have a technology like a drive, an S120, for example, if you want to know more about drives, I saw some on Jason's channel over there. No, I mean, I laughed, but it's true. Like, there's interesting stuff going on, which I will also have a look at. Yeah, so now in here, right, I do have a lot of settings. And you see, if I go to the parameter view, a real PID controller is not that simple. Like, what I made is almost, it is pretty much nothing in contrast to a big real controller. I talked about some of the parameters, but most of this, like, engineers already did this in the past. There is knowledge we can use, especially as an automation person, engineer or technician or programmer, whatever. You want to use what's already there. Right? Now, I want to use this know-how. I want this to go into an automatic mode when I start it up. This is general. I could also say, hey, we actually want to have like a, what would that be? A volume, for example. The volume should be in liters. Sure, why not? The input, I want to take the input is input not from an analog input sensor, but from an analog input value, which we have. We have a real value. And the output should also go to an output and not an analog output, and so on. There's so much we can configure in this. And I'm just brushing over it real fast right now. Right? So for example, process high value. So the limits I also had in my system there, right? Where the process limits would be from 0 to 10 actually. Yeah, it would be from 0 to 10 because that's what the set point and the level meter give us. I think if I remember correctly, should be. Like, we did some scaling manually in my block, right? This all happens here, of course, automatically. And we have the value limits. We don't have the process value scaling. That's not in there. And we also have, and this now is the most important part here, of course, all of our PID parameters. And there you see we don't just have PID. Right? I talked about PID. We have way more. Right? We have the proportional gain. We set this up. I talked about integral parameter, whatever that is, which is not perfect, right? The integral parameter, that's a random thing. There's many, many different methods, right? And this now is the integral action time. The integral action time, right, is like, if we have an error of 100% over 20 seconds now, we will have an integral action of 100% as well, so that the value doesn't run off. Like, inside of this block, so many things have been considered. Plus, we also have the derivative. And you see there's so many factors in here as well, also including the sampling time, where the only thing that I will now change, because I will do a manual entry here, is the PID algorithm right now calculates once per second. Right? If we calculate this, the sampling time, this we also consider the sampling time in hours, right? It was 10 milliseconds. Now the sampling time for this one is by default like 1 second. Let's make this faster. Let's maybe make this 10 milliseconds. Yeah, sure, why not? Might be too fast. 10 milliseconds might be too fast because the PLC cannot keep up. We will see about this in a second. That's it. Right. Now, the only thing, I cannot have this in my interrupt block anymore. I will now have to put this in the main block because the interrupt block would definitely be way too slow. All of this, a ton of bonus information that is not too necessary right now. I will now download and everything is just going to run smoothly. And I'm just sad because everything that I set up, including, by the way, this also comes including its own, its own trace thing automatically. So we don't need to tune, we don't need to do anything. The output here, the set point, the input is very close to the set point already. This works magically already. And let me reset the simulation. And now, right, we will see if I now, Hey, the integral part is actually acting. What an idiot. Same problem that I have. If I turn on the set point, you will see that the controller here itself is doing the same thing that ours did, but already way better. Now, one problem that we have with this right now is that it is acting quite slow by default. Now, if this thing acts slow by default, I want to turn this off right now. And there is something called tuning. So now what we can do is I can simply click here on tuning, right? And consider one thing. Right now, those are our PID parameters. And I'll make a screenshot. Those are our PID parameters. Can I have this side by side? Yeah. Now we could calculate this and we could program this and we could do so much with this, right? Or I could just click on start. Process value is too. Ugh. Yeah, the set point is 0. I cannot tune if the. My bad. Hey, why is this? Why is it acting? Stop it. So I just clicked on tuning, and with tuning, what the system does, it actually turns on to 100% and then off to 100%, and it looks at what is the system reaction, and it will change all of our PID parameters here, right, to like very good parameters. Nothing I have to do. Pre-tuning worked terribly, depends on your system, depends on what you try to achieve. It is very difficult, but it should be good. And I will get back to in a second there with the chat, sorry. And now our system should be tuned very nicely. So if I reset this and I set the set point to like 50% here maybe, this should go there very fast. The only problem that we have is that the integral is still running off. And I don't know where to deactivate it right now, but I will find it in a second. Why is it running off? Just 1 second. So one thing that I do now is whenever, and this is so similar to what I did with mine, right? Is in my PID compact, in my block, I was always going into the data block to look at the parameters. And I can do the same here with the technology object, right mouse button, open the data block editor, which will go into all of the parameters, where we can see the integral sum actually run away, right? Which should be a static value. There should be a value probably in the PID control here, the integral sum. And you can see the integral sum is doing something very, very fascinating probably, but I don't know what exactly it is doing. But I can reset it manually. So I can also override the technology object, of course. Goodness gracious. And if I now turn on a set point here, you will see the integral sum will go up, should go up. Why isn't it? Hello. Oh, it does go up. It's just not. It's fine. It's doing something fine, I guess. My controller would have been better. So now, but that's it, right? Right now, look at this. This is just going, it's not going perfectly. Why is it so slow? What the fuck? Sorry. I don't want to curse all the time, but I'm sometimes surprised what's going on. Huh? Oh, look at this. Because we auto-tuned, something messed up with the simulation. Because we auto-tuned, you see that the sampling time of the algorithm is now 7.4 seconds. That's why the value only changes every 7.5 seconds, which is not correct. Let's lower this. Why would I want this? So now it should be cleaner, it should be better. Not going like this is now. This is now heading into territory. But this would be... There are almost waves, yeah. We almost have the oscillations there again. Damn it. This is so unclean now. This was... But you see, we have the PID object here, the PID technology object, and now it is just running. We did not need to configure too much. Now I rushed this again. Like the last hour was just rushed. I do apologize. Right? I do apologize, but yeah. Do apologize for the rushing there. Yes. But what I wanted to get at actually is the PID compact block. This was now extremely easy to implement, right? I popped in the block. I put the same parameters that we have used before, right? Our set point, our level meter, the fill valve. I have used the same parameters, just popped them in there, went into it, gave it some parameters, not too much even, right? Just changed some parameters that are very logical to change and had the whole thing tune itself. The automatic tuning did not work at all. The automatic tuning messed everything up. Not most likely, but pretty guaranteed because of the simulation system that we're using. PSC Sim in combination with Factory IO. There's a lot of delays everywhere. So it makes sense that it messes up things. Yeah. This looks just messed up now. Now with the system that is absolutely untuned, let me try to tune it once more and then... Okay, please stop now. There's a stop button down here. I pressed the stop button so that it's not acting. This is like resetting the, what's it called? The integration, the integral part. So what I want to do now is set this to approximately half. Right. And now when I turn on the pre-tuning here, that's what I want to do. The PID values, like all of the values, not just P, not just I, not just D, but all of the corresponding parameters here. Right? They should now change to decent values. I doubt they will because of the simulation interface that we do have. Simulation is pretty bad. So I clicked on auto tune now. So it turned on the whole thing at 100%. And it turns off the whole thing. And then it measures the reaction, the so-called system, die Sprungantwort, the system reaction, and the step response. And now we should have a nicer, like we should have nice parameters. We won't kind of have nice parameters. This went better. The second tuning went way better than the first. 1 second here. I don't care about this. Ugh. Scrolling through this is terrible. So this, why is it so cut off? Because we only calculate every 100 milliseconds or so. I can't remember the sampling rate. What sampling rate did we actually give this thing? We gave it a sampling rate of 100 milliseconds. Right? So it only has a new calculated value every 100 seconds, and that's the red part and the green part. And the red part, why we only have a new value every 100 milliseconds, because that's the output of it, of course. Yeah. Now, one big problem that we have. No, not a big problem, but this is very slow. You see this, that the green part is our input value, like the fill level in the tank, and the black part is the set point. That's where we want to go. So the system is still filling up, but it's very, very slow. The P part here in the beginning should react for a longer amount of time. Right? So this is now very, very slow. So the tuned values are pretty damn bad. They should be much. They should be much better. Auto tuning sucks. Goodness gracious. Okay, Let me read through the chat there for a second while we watch the graph grow. It will reach, but it will be very, very long. The PID parts are very off. Give me a second. I just want to fix this. So maybe make this 20, we said. The integral acting time is maybe 30 seconds. The derivative action time, which we haven't talked about at all, I don't know. 20. The higher the numbers, the less strong they act. No, other way around. Damn it. Let's make this just a PI controller. Oh god, I messed it. Look at this. Look at this. Oh no, chat is off topic. Okay, if chat is off topic, that's perfectly fine. Why did you have to manually reset the integral sum in the PID block? Pranav, I did have to do it because I did not stop. If I stop here the PID compact, I would also reset the integral part. Small numbers on the integral depends on how the system is set up. Yeah, that's why, but it depends on. The integral action time, the bigger it is, the small. The proportional gain is way too big right now, that's why. So now I could just play around with those values a little bit and test out. Oh, God. Or I could disable this. I could give this a last shot now by resetting this, giving it a set point, and hoping for the best once I say pre-tuning. So right now, those are our values, right? The set point is 5.2. The input is 0.0. Once I press on tuning, the output should be 100 for a certain amount of time. Then it should be 0 for a certain amount of time. And then it should have calculated the values manually. Right? Or it is 0 first and then 100. Don't know. Don't know the order. Don't know what it's exactly doing. No, it should be 100 and then it should be 0. Oh, other way around. Okay, no, it's 0 and then it's 100. And it now TIA and the PLC and the controller here itself analyzes the step response. Like, how is the system reacting on this change, and is recalculating the PID values. And those look really nice now. Oh, the derivative part, the D part. Now this is good. This is a good controller. Finally. Oh, at the last part of the day, we finally have a good controller. Now, mine was good, but this is now also good. The derivative part was acting up because the error in the communication of the simulation, I 100% understand now. So turning off the D part actually fixed all of our problems here. If you ever use the D part, be aware it messes up everything. Right? PID is hard to tune with fluid systems because of noise. Depends on the system, but yes, Oliver, you are completely correct. PID is hard to tune with fluid systems. Yes. I mentioned the second way to reset the integral in the PID compact different than auto manual switching. Yes, Artico, you can at any time in any part of your program, right, your PID compact, right, this one here, it has its own data block, right? So you can go right mouse button, open a data block editor, and it has the PID part, if you want to, as the integral sum. I could have this integral sum somewhere in my program, right? And I could have this, I could just push a 0. This is a normal variable. You can just put a 0 in this at any time in your program, which means resetting the integral sum. So you can use this variable. Yes, logical controls. I believe most controllers are usually only PI anyway. Yes, most controllers would be PI. The D part you have to have a very stable system in order for the D part to really be effective. The D part will speed up everything. As you saw in my case, the D part will speed it up like crazy. Like, it will speed up the change because of the change in error. If you have like even like the littlest, most simple like measurement error in your sensor circuit, right, you will have the D part reacting extremely strong to it. So you have to have a very nice system in order for the D part to optimize something. Most systems would be PI. But in the documentation it says it's not recommended. It's not recommended. I just say it's possible. Yes, resetting the value here, getting in there is not recommended. Yes, but you can do it if you want to. Normally, what you would of course do to reset the internal values of your block here is there is a reset input. if you want the official, like the easy thing there. You have this reset input. If you turn this to true, of course it will reset. Right? You have that input. Yes, logical control is very good there. The question was like why is the value between 0 and 10? Well, the valve is. Our system is set to 0 to 10. That's just what we get from the from factory IO here. You see all of the values here, the fill valve, the level meter, the set point, everything is also 0 to 10. That's why I scaled it into that. You should have a reset input. Does that not exist? I mean, they change things all the time, but there should be like a reset thing. Or maybe a reset mode. Maybe you have a reset mode instead. Don't know. D is like amplification of frequency. It will amplify any error frequency in there. The D part makes everything very, very aggressive. So let's see, actually, do we have the... Hey, Jason, that's for you. Look at this. I auto-tuned the controller. No. It did the thing. It did the thing. So the first problem that I had with this auto-tuning now, right, is that we do have a very big overshoot here in this place. Right? We do have a very big overshoot, and we have oscillations going on. Errors that will get strong, and you see in the end we just have ripples. We have the waves. This is bad. And if I look at my system, that's probably what we will have. Yep. There we go with the ripples, the waves. Now this is not like the auto tuning. Okay, the learning outcome here. I mean, now we could continue with this. This controller, by the way, is good. Like the PID compact block is usable and it is good. Also, auto tuning is good. The problem that we now have is it's not tuned correctly because mostly of the simulation. Now, what we could do is we could now enter fine tuning. That's what we would need to do now. And that's the second step. You see, I'm now fine tuning, so the values are adjusted again. Once you adjust the values when your system is empty, and once you adjust the values when you have something in the system. Right? That's what fine tuning is for. And now with the fine tuning, which takes longer time, the values are adapted so that we do not get those waves. Right? Should. Can't guarantee, but we should actually get there where it's not that aggressive anymore. So Jason says D is really susceptible to noise in the feedback. That's what I mean with the sensor loop. Like if you have any small thing in the sensor loop, your D part will react way too strong. Deep always depends. Yeah. And you're all saying the right thing. Yeah. If it's already stable, D can improve everything. Sad I cannot do the auto-tune in my application. Yes, auto-tune only works, and you see it's still tuning, right? So the system is still tuning. It takes a longer time. If you have a physical system, you can't just always go there, interrupt it, and just turn on the tuning. That is for the testing phase. That is for like really improving the systems. You can't always just go there. No. Usually you would still have the step response, and you would manually calculate a lot of things. Welcome to the world of automation. Welcome in engineering. It isn't that easy. Good. But we are back on a good track. Sorry for like, now it took 1 hour longer. Now, sorry for like being off track. I've not been really off track for a long time, but I've made a small mistake, which led me into, this was me. Right? This was me. I was doing good. The green one, right? I was doing good, like we were going good, everything was fine, and then I was overshooting the target. I wanted to integrate the integral part to our controller here. This was my hubris. And then the time, like the time went down. Like I was like the red one. This is our critical part here. I was losing myself into the integral part. And at some point I realized, oh no, we can't really move on like this. No. And this is when I switched back over and fixed everything. And now if I do not pay attention too much, we're gonna have more ripples there. Like it's not gonna be good. Right? But yeah, that is the that is how the stream kind of went. Was good, and I was overdoing it at some point, and I lost control for a second there, which can always happen. But now, system is tuning, and it's good. This was your hubris. It was my hubris. I was like, we can do it. And we could. The best controller still was my PI controller. Don't forget that. Yes, Logical Controls asks, if you manually set up the PI and D, does fine-tuning totally change the values? Yes. So those values that you have here, right, they are in, I have manual entry enabled. However, the auto-tuning will override those. Yes. Right? So that's what it's currently doing, right? It will at some point, I will still wait for the fine-tuning to be done here. I don't know why it takes so freaking long, but it should be done in a minute or so. And then those values will probably have changed. Yeah, they will have changed. Yeah. No, it was a great stream. I had fun. I was learning a lot, but I like, imagine if we would have time constraints, if I would be like your teacher in university or so. And I would be off topic for like an hour. That would be that would be very critical, which happened to me in the past. Right? So I used to be teaching university level classes and so on in class. And some of the professors, they always, like in the break time, there was already like between me and one other, like I'm not professor, I can't say professor officially, but me and another teacher, he was a professor, I was just a teacher. We had this joke running because every now and then I was just going over time for so much. All of the students liked it. Like we had great classes. The learning outcome was great, but I was just going too much, and my timing was so bad. Ah, God. And oscillations were not that bad in the stream. We could just follow a tuning method. Pranav asked, right? What will be the topic for next week? Yes, like I don't really think about it like already now, but we have many topics. Right? I will always have to choose one. Right? This is now not perfectly done. Right? Where is the PID is like I would say it's almost half done. Like I'll put an X there because for now it's done. Right? For now it's done. Hey Coit, haven't tried Factory.io. Is the tank sim available on it? You can download it. There's a free trial period. If you like download Factory.io, you can get like a month free trial period. Yeah, I won't link it, but it's available. So that's there. We had sequential programming. I want to enter, wait, there was a topic that I definitely wanted to enter because it was asked already a couple of times. Next time what I want to do is I do want to look at software units, which is a nice feature our PLCs have. And I want to look probably a little bit at SCL with this. Right? And today we also looked a lot actually at libraries. So look at this. Hey, we have a couple of topics that we actually talked about. Right? So my assumption for the next time will be software units and a little bit of SCL, a little bit of programming. Yeah. Don't know yet fully though, but those would be like things that I have on my mental list. Might be anything else, depending on what comes up though. I usually let you know on Monday, like in the title of my videos, of my live streams. I usually let you know on Monday already, so that you can, like, that you know beforehand. Yeah, Teko, I know. Like, the tuning is like a huge topic in itself. And you see, with the fine tuning now, we do have different values. Where one problem now, what is this, please? What? This is not tuned. This is oscillating again. No, it is. It is done. Fine tuning is done, but it is trash. Look at this. So, learning outcome: the best controller today was not the PID compact. It was the Hega process control block. There we go. That's the one. That is the beast. That is the best one here, right? That was it. Oh no. I mean, it worked. It worked better than I would have thought, actually. But yeah. And this was the fill valve, right? So that was okay. Now I could still improve this, but there's no need. Like, when we want to learn, there's no need to improve this now. But yeah. Oh, good. Let's see. So I will slowly phase out here, right? I still had a lot of fun. Like, even though it didn't work perfectly now, I had a lot of fun. This is great. Thanks for joining. Like everyone, like, thank you for the chat there as well. Sorry that I couldn't be there for a hot minute because my head can only be in one place. I'll still answer some questions. So if you have some questions, like last 5 minutes, and then I'll wrap up for the day. It's been 1 hour too much. Oh God, those are way too long. What does WhatsApp say? Gotta look at WhatsApp. This is the best type of stream. When we run off, it is fun. It is great, but I mean, we have a good result. That's what we need. Let's see. Turham asks, how would you recommend someone to get into automation? Someone with electrical and engineering background. Well, education is always the best, right? And maybe an internship with a bigger company. Right? In Germany, my introduction to automation was, I applied for like a dual study program inside of Siemens. So I got into a dual study program with Siemens. But the best part there, where I really got into automation, was my internship phases. So I did internships like in different Siemens areas, and that was where I really got into this stuff. Let's stream about safety. So Artico also asked, where did you stream about safety, like Profi Safe, hardware stuff related to safety? Let me put Profi Safe on here, but not right now, because Profi Safe, simulating it and showing it is very difficult. Extremely difficult. But I'll add this, but not in the near future, definitely not. Let's see. Alexander, a teacher of new technologies is just a person who has enough prior knowledge to quickly master. That's what I do. Yeah, you're right. Yeah. Like that's what I do. I can adapt to new things because I have already experience. And second part there, from Alexander, how can someone be a top teacher of something that was created a few years or months ago? Thanks for your effort. Oh, that's not a question. I thought this would be a question. Yeah, you're welcome. Let's see. IG Bine YouTube. I'm new. Where do I start? From my YouTube page. Where do you start from? Hey, look at the link. I do have a Udemy training. I need to plug this, right? I need to. There. Oh, look at this link. Oh, if you're new to the topic, go there, get the course. Or on my YouTube channel, I do have, I think, a couple of playlists, and one playlist says basics or so. Like on my YouTube, there is a like I do have like especially for beginners, go into playlists. I do have several playlists. Digital fundamentals. Yeah, that's it. Thanks, Jason. That's the one. You know my channel better than I do. So Jason has it correct. Like there is I think it's not a course. Course is a new concept in YouTube. But it's playlists. Look at the playlists. Thanks. Thanks, Jason, for telling me what oh God. You earned that wrench. You earned the mod state here, the mod status. Thank you very much for the link. Hey, you can put links. Thank you. This is cool. This is, oh God, now I feel like a real streamer, like a real YouTuber, stuff like that. It's crazy. Thank you. Logic Controls asks if I use, do you use Siemens PLCs exclusively? Have I worked with any others? I currently do Siemens PLCs exclusively. I have worked with many other types just to get into the topics because my beginner steps, what I did actually mostly in education was mechatronics itself, right? So mechatronics and industrial mechatronics and industrial automation uses controllers, where Siemens is just one type. There's of course other types. So when I started, I used plenty of different types. And in the classrooms, I used plenty of different systems, like the Festo MPS, for example, right? Where in the classrooms, you see those systems. For example, this is one that I still kind of regularly use, where the... Do I have a good screenshot? What is wrong with the screen? What the pictures here? Where this is the case. Like those systems for the classroom. In the classroom, I'm mainly a teacher, right? In the classroom, you see they have those different PLCs. Different. There we go. They have exchangeable PLC slots. They have one connector with like 32, 64, I don't know how many connections in there, but you can unplug the Siemens controller and just put in a Mitsubishi and Allen Bradley, whatever controller you want to have, right? So you can pretty freely exchange those. Those Festo trainers are pretty good, yeah. I've used those plenty. One time I was also at WorldSkills. If WorldSkills rings a bell, I was once at WorldSkills, not as a student, but as a teacher. That was fun. We completely failed everything, but it was still fun. Yeah, and I for those things, right? In mechatronics, I was there in mechatronics for those things. It was cool. And I know the people that that develop those systems. I've worked together with them for quite some time, for Festo especially. So answering that question. Let's see. Got this. So Jonas has just finished my electrical education and used an old 1215. My videos are a big help. You're very welcome. Not a question there, but still very, very welcome. Although all my videos I think I've done with 1500s, but the basics are the same. So Oliver, now this question is this question is of course this could be interpreted in many ways, right? When can we see a robot program? That could mean that when will you see me program a robot? Haven't done that in some time. Or on the other side, it could be like, when will I be replaced by a robot? Physical. That could be a possibility with AI at some point. Not gonna happen soon though. Hey, Logic Controls. Do I use Fluid Sim? And I'm almost like 1-2 more minutes. Do I use Fluid Sim? Wait. Let me go into incognito mode. Let me see. Fluid Sim. Wait, 1 second. Maybe. Fluid Sim. Damn it. It's so long ago. Nah, this is not getting pushed. Oh, come on. Come on. I hope for it. Fluid Sim, here we go. To answer your question, why is it not even showing up now? Are you kidding me? Yeah. I do have I do even on my YouTube channel have a Fluid Sim playlist, yes. God damn it, my videos. Oh God, I was wearing glasses back then. Yeah, look at me. I was a kid back then. I think this was even 7 years ago. Oh, whoa. This is so long. Yes. I do, that's a flex. I know it's a flex. But I do have a playlist. This playlist is also like a couple of 200,000 views. Look at this. Yeah, this is a flex. And with this flex, I would say let's wrap up for the day. Yeah, let's see. The infamous. How long do I have access to? You have unlimited access. If you get the Udemy course, of course, you have unlimited access, yeah. Of course. If not, then let me know. But it is like you get the course, you have unlimited access. But I don't have control over this. Look at this young guy doing fluid. Oh, fluid. Oh, this is like you look at him. God. Another ad. What is YouTube? Oh, by the way, a question for you. Right, a question for you. Was there any was there any ads playing during the whole live stream? I think I turned it off, I'm always with the settings. It's always like I don't know what's going on. Baby Morale, yeah. You will buy it. The info is you don't have to buy it, right? But it's good for introduction, and it helps me as well. Wait for a sale and so on. Right? But if you buy it through my link. That the proceeds go like 70% go to Udemy if you don't use my link. It's crazy. No ads. Sorry, don't do whatever you do. You do you. Sorry. Uh, let's see. You use Brave, so no ads at all. Okay. Use Brave. Oh, you all have this. You have premium, really? Okay. I think I turned it off, so there might probably no ads. Another week to wait. That was super awesome again. Thank you very much, Coit. I think we will leave it at that, right? Have I worked on Target 1500's MATLAB to Siemens.com? Ooh, that's interesting. I have not linked MATLAB to it. Maybe something for the future. I'll put MATLAB on the list. But then I would probably use Scilab, which is very much the same thing, but free. MATLAB is too expensive for me. There we go. Yeah, no, we will leave it at Coit's comment there. Perfect. Thank you very much. Another week to wait. If you can speak German, I do stream on Twitch. Not all the time, but way more than I do on YouTube. So if you have questions, you can always hop over on Twitch as well. I will also answer English questions, but I will stream in German on Twitch. But yeah, we'll wait a week. I do already have some ideas what we do. So yeah. Thank you so much for joining. Sorry that we detoured here and there, and sorry, Jason, that I really couldn't get into now reacting to anything. If you do have a stream, Jason, let me know, and I will hop onto yours. Yeah. Whew. But now I also need a break. This took way longer. This took a lot of energy, also brain power from me. Goodness gracious. So thank you very much. Have a great evening, and I will see you the next time around. Bye bye. Where is the button? Have a great week. Yes, thanks. You too. Where is the button? I pressed F5. Oh no, have a great week. Bye.